at the feet of our founder Swamiji, Swami Siddhavananda Maharaj, Swami Vedananda, Secretary of our college, Swami Adhyatmananda, Kulabari of our college, and the dynamic principal, and all other participants, chief guest. Good morning, one and all. First of all, I welcome our Secretary Swamiji. By the magnanimous support of our management, we have a new lab in our department. They believe us, they encourage us, they motivate us for all the activities of our department. So in this record, I extend a wholehearted welcome to our Secretary Swamiji, Swami Vedananda. Next, I welcome our dynamic principal, sir, Dr. T. Venkatesan, who has been sacrificing his life for the development of our Kurukula. Arts people. He always thinking about the development of our department. In this record, next I welcome today chief guest, Department of Chemistry, School of Chemical and Biotechnology, our invitation without any hesitation, Bharati. So in this regard, I extend my whole heart welcome to sir for this program. Next, I welcome Dr. Nehru, Assistant Professor, Department of Physical Chemistry, School of Chemical Science, University of Madras, who is very young and energetic. He accepted our invitation over the phone. Design gas sensor for environmental and health monitoring application. Finally, I welcome our proud alumnus, Dr. V. Rajendran, Assistant Professor, Department of Chemistry, School of Basic and Applied Sciences, Central University of Tamil Nadu, Thiruvarur. So 4 days back, I called him. Even though he has a lot of work on this day, he gave us preference for our campus. It shows his love and affection towards our department. When I was doing my PhD in the year 2007 at Bharat University, there he was the senior-most man in our hostel. Also, he used to have a lot of activities regarding academic as well as to have well-wisher for our department. Welcome to you, sir. Next, I welcome convener and coordinator and a happy welcome to all the country. And I welcome all my students and all my teachers, dedicated teachers who are supporting me to do lot of things in our department. Once again, all the people who are gathered here. Thank you so much.
Okay, sir. Thank you, sir. Now I would like to invite Principal Dr. T. Venkatesh to give a presence address.
So first of all, I submit my pronouns at the feet of Founder Swamiji, the most respected Secretary Swamiji of Vivekananda College, Swami Vedananda, the most respected Swami Adhyatmananda, our beloved Vice Principal, Pradi, our beloved Dean and Controller Dr. K. Karthikeyan, our beloved IQAC Coordinator Dr. Sadish, Department of Chemistry, Mr. P. Sevaramuthu, the resource persons for this faculty enrichment program, Dr. S. Devaraj, Dr. Nehru, and Dr. B. Rajendran, the conveners for this faculty enrichment program, Mr. Rehu and A. Dharmanandam, the faculty members of the Department of Chemistry, faculties from various colleges, universities, scholars. So good morning to everyone. So first of all, I congratulate the Department of Chemistry for arranging this faculty enrichment program on advanced materials applications. You all know about the chemistry is a big part of everyday life. So we can find the chemistry in our day-to-day life, the food we eat, the air we breathe, the medicine we take, the chemical we use for cleaning, even in emotions, and literally every object we can see and touch. The Department of Chemistry is now headed by Mr. Servaramuthu. The faculty members of this department, Dr. Ganapati, Dr. Kannan, Dr. B. Rajkumar, Mr. Rehu, Dr. D. Tirupati, Dr. G. Balakrishnan, Sri A. Dharmanandam, and Dr. S. L. Raja are the faculty members of this Department of Chemistry. Today, this department is arranging this faculty enrichment program on advanced materials and its in the chemistry. The chemistry deals with the study of changes when one element is added with another element, when one element is added with a group of elements, or originated from a group of elements or feel the changes. So similarly, when a person or student enters into our college, the student can feel the changes in this Vivekananda College gives primary importance to life training. So this institution is a man-making. Our institution is focusing on inculcating the spiritual, ethical, moral, and social values in all disciplines. Was established by Swami Sidbhavananda in the year 1971. So this year is the Golden Jubilee year. It is an autonomous in 1987 by UGC. So we already re-accredited by NAC for 3 times. UGC also granted with the status of college with potential for excellence. Focusing on 3 important components: hand, heart, and head. Students perform physical jerks in the early morning and yogasanas in the evening. So in addition to this, they practice martial art, karate, silambam, and malkam. So these physical activities help the students to attain the value of self-confidence. The heart part, it indicates the spiritual culture of our students. So our students perform prayers 3 times in a day for 15 minutes during morning 8 o'clock, in the noon 1 o'clock, and 6 o'clock. So this 15 minutes prayer gives enormous secret of true progress and peace in the minds of our students. Regarding head part, it indicates the knowledge and wisdom of our students. So this Vivekananda College is pioneer for quest of excellence. So in addition to that, we inculcate many values to our students: the value of silence, the value of conquering the tongue, the value of community living. The Department of Chemistry was started in the year 1981, and it was elevated as a research department in the year 2005. So this department is always motivating scientific aptitude and skill development in the minds of the students as well as in the minds of the faculty members. There are more than 3,000 library books in this department. Department is organizing this faculty enrichment program on advanced materials and its applications. The resource persons, Dr. S. Devaraj, Senior Assistant Professor from School of Chemical and Biotechnology from Shastra Deemed University. And another resource person, Dr. Nehru, the Assistant Professor from the Department of Physical Chemistry from School of Chemical Science from University of Madras. Dr. V. Rajendran, one of our proud alumnus Now he is working as assistant professor in the Department of Chemistry from School of Basic and Applied Science, Central University of Tamil Nadu, Tanjavur. So these three resource persons today, they are going to discuss on advanced materials and its applications on behalf of management, staff and students of Vivekananda College. I congratulate these resource persons. I also welcome and my wishes to these resource persons. I congratulate the team members under the headship of Mr. Servara Muthu for organizing these type of faculty enrichment program. I wish all the participants, one and all, thank you.
Thanks, sir. Very nice presence address. Next, now I would like to invite Dr. S. L. A. Raja, introduce resource persons.
Thank you, sir. Can you hear my voice?
Yes, sir. Yes, sir.
Thank you so much. At the outset, I personally feel thankful to the Department of Chemistry because amid this COVID-19 2.0, our department is successfully entering into FEP7 program under the dynamic lead of Sri Servara Muthu, sir. So let them congratulate. And today is a great day. We are fortunate to have Senior Professor Dr. S. Devaraj, Senior Assistant Professor, Electrochemical Energy Lab, Department of Chemistry, Center for Nanotechnology and Advanced Biomaterials, School of Chemical and Biotechnology, Sastra University, Tanjore. Professor has received his BSc degree at the American College during 1998. Then he was recognized as gold medal in MSc Chemistry at the same college. Then he switched over to Indian Institute of Science, Bengaluru for his PhD program at Department of Inorganic and Physical Chemistry during 2003, and his thesis is highly recommended. Then he just enriched his research knowledge as a research associate during 2009 at Indian Institute of Science, Bengaluru. Then he went for National University of Singapore for his postdoctoral research fellow. From April 2018 onwards, he has been continuing his research career as Senior Assistant Professor at Department of Chemistry, Center for Nanotechnology and Advanced Biomaterial, Sastra Deemed University, Tanjore. He has a combo of various awards, fellowships, and recognitions, and I'm happy to note some of the important awards received by him. He was a recipient of a lot of awards from the various journals like Journal of Alloys and Compounds, Journal of Material Research Bulletin, and he was a recipient of yearly Career Chemist Award from Pacific Basin Society, United States. He also a recipient of Young Scientist Award from DSC Sir during 2014 in India. He also cleared JRF organized by CSIR India, and also he received various gold medal in his PG as well as UG studies. He has been operating so many projects under various funding agencies, remarkably in labs, especially DST SERB as well as UGC DACSR. Regarding to that, he has published so many research articles, especially in Journal of Electrochemical Society, Electrochemical Acta, Chemistry Select, Journal of Energy Storage with a high impact factor. He has completed 3 PhD students and 2 MTech students and 10 MSc students, and 2 PhD and 2 MSc and 10 BTech students are in progress. He also has various patents, especially nanofluids as an additive in the electrolyte in Indian patent, as well as ocean water generated hydrogen as a fuel, as well as in Indian project. He also authored one book chapter entitled Energy Science by McGraw-Hill Education India Private Limited. Regarding to his research career, he has attended so many conferences, seminar, and also acted as a convener and coordinator also. Regarding to his teaching into, he just teach electrochemical energy conversion storage characterization technique regarding to nanomaterial synthesis as well as nanofabrication. mostly in electrochemical analysis and engineering chemistry. He also has some professional appointment like board of study member as well as IKSC member in Shastra deemed university. So with this brief biodata, I'm very happy to invite Professor Devaraj to deliver his lecture on improving the capacitance properties of reduced graphene oxide by tuning the electrolyte. Sir, welcome you, sir.
Thank you, Dr. Ilayaraja. That was really a lengthy introduction. Thank you so much. So kind of you, and very good morning to everyone. And thank you very much to the management and head of department for having me here for this faculty and enrichment program. So I shall share my screen now.
Yes, sir, you can.
Is my presentation visible?
Yes, sir.
Okay, so I'll go for a full screen and take the laser pointer.
Yes.
Right, once again, thank you for the opportunity to present in the FEP. And I'm also related to Vivekananda College in the sense that I'm not an alumnus like Dr. V. Rajendran, but one of Vivekananda College student is actually my student. So in fact, my first student is actually an alumnus as well as the former faculty member of the Vivekananda College. So in that sense, I'm also related to the Vivekananda College. So today what I'm going to talk about is improving the capacitance properties of reduced graphene oxide by tuning the electrolyte. The work carried out by Dr. Bharidasan, who is an alumnus of Vivekananda College. I actually prefer my talks with a question. So the first question which I would like to ask is clean energy really critical? And everybody who is on board in this lecture knows the answer. The answer is yes, clean energy is really critical, right? These pictures actually convey the message, right? I would probably put a little bit of statistical information and photographic evidences to convey the message that yes, clean energy is really critical. So what you see in this graph is basically the oil consumption. What I refer oil here is basically the fossil fuels, the petroleum, crude oils from which we get the petrol, diesel, and many other products, right? So our consumption of the oil actually is going up. And if you look at this bar chart, which is basically tells you how much we are actually extracting it, right? And that you can see that it's actually decreasing. So there is a certain gap exists, and this gap is actually keep on increasing. Okay, and this data is actually, I have it only up to 2005 or 6, but you can extend up to 2020 now. In fact, the gap is actually larger than what was projected in the year 2003. So it's very clear information from this graph is that the amount of fossil fuels we require and the amount of fossil fuels what we extract and refine, there is a large gap. So which means that we are not able to meet the requirement. And when you use the fossil fuel for the industries and for the transportations, we irrevocably, irreversibly, we damage the environment by emitting a lot of greenhouse gases, including the carbon dioxide and many other gases, right? So one hand, you have the resources getting depleted fast. On the other hand, we are damaging the environment, right? So if we continue to use the fossil fuels, probably for next 20, 30 years, we would probably end up in a situation of wearing a mask even inside the home. Now we are wearing a mask for a completely different reason. That's because of the pandemic. As one of the persons mentioned that even in this COVID situations, college is able to organize a FEP. That's really a very good news. The empowerment and enrichment of the faculty should not stop because of this. So the reason why we are actually presently wearing is to prevent ourselves from the virus. But if we continue to use the fossil fuels probably for the next 2-3 decades, we will probably end up in a situation of wearing the mask inside the house itself. So this scenario is already there in some of the cities which are highly polluted. Probably if you Google it, when you have the time, the most polluted cities in the world, there are few cities from India is also in the top of the top 10 list. Right? That's a news for us to really wake up, right? To avoid the environmental damage. Just to give you an information, if you have 1 liter of gasoline, which if you burn it, not in an IC engine, not in an internal combustion engine. Okay, just you fire the 1 liter of gasoline completely into carbon dioxide, it is going to give you 1.5 kg of carbon dioxide. Okay, this number might look small because it's given in weight, but when you convert it to the volume, you will understand the real impact of it. It is converts into 750 liters. What it signifies is that if you burn 1 liter of gasoline completely into carbon dioxide, not in using it in IC engine, you actually give 750 liters of carbon dioxide, which is a very, very huge volume. Okay, fortunately, we use gasoline in IC engines, so which works at the efficiency of 40%, which means that the amount of carbon dioxide which we emit is less, and also we have the catalytic converters and other things which actually traps the carbon dioxide to some extent. Otherwise, the air damage which we cause to the environment is really very, very high. Right? So the clean energy is really critical for three most important reasons. One is the depletion, which is getting fastly depleted. Right? Second is the environmental impact, and the third one is economic situations. Right? Even during the pandemic situation, I'm talking about the situation which we were in the last year exactly in this state, March 2020, probably end of March 2020. Right? We had a lockdown. Almost all the cities in the world had a lockdown, right, except a few. So the oil prices seriously gone down, but the petrol and diesel prices in India did not really go down, right? This is to do with socio-political issues as well as the economical issues, right? So there is an economical issues also attached with using the fossil fuels, besides the environmental issues and the availability. So for these major reasons, we need to find out the clean energy. And for every question which we post, I believe nature has an answer for it, right? So the nature gives you an answer that there are sustainable energy resources available, okay, in the form of solar. Especially country like India should not really worry about it because we get the solar spectrum in almost all the parts of the India throughout the year, right? So we have a solar, we have wind. In Tamil Nadu, windmills operate with the highest possible efficiency about 3 to 4 months, which is more than 1/4 of the year, which is excellent, right? And we have hydropower and biomass. So we have a sustainable energy resources, which is we are blessed to have by the nature. But what is the problem with this? They are intermittent. What I mean by intermittent is they are restricted by space and time. For example, solar, we get it in the daytime, right? And how about in the nighttime? We don't have. Wind, as I said, you get it only 1/4 of the year, slightly higher than 1/4 of the year. How about the other months, right? And the same goes for the hydro and biomass. So they are restricted by the time. They are also restricted by the space. We cannot have the windmill installed in every house, right? It has to really go outside, outskirts of the city for the safety reasons. And hydro, we have to construct a dam, and you tend to construct it where there is nature provides an options to construct it, right? So likewise, it is certainly restricted by the space and time, right? So whenever you have the opportunity to tap, you need to tap and store it to supply uninterrupted manner. So the storage is very, very crucial. So I'm going to talk about one of the storage devices, right? So clean energy is critical. And we have the sustainable resources by which we can prepare, we can derive the clean energy, but those sustainable energy resources are intermittent, so you need a storage. Storage is very, very critical in the sustainable development of our nation, right? Just to address the intermittency some more, this is the chart which actually shows you the energy derived from the windmills in the California, right? Over a period of 31 days in a particular month. I think it's in October. For more details, you can actually go through this link, right? Throughout the day. So you can see that for any given day, the amount of energy derived is not the same. Let's take a day 18, for example. And the first hour, you have somewhere around 3,000 odd megawatt, and then it decreases. It decreases down to 6th hour and then increases, then decreases. You can see that it is actually fluctuating, windmill. Okay, right. If you take day 18 with any other day, day 2 or day 15, day 21 or day 31, it's not going to match, right? Which means that across the day, across the month, across the week, across the year, we are not going to get the same energy output from the windmill. Whereas the requirement is also, though it is fluctuating, we need to ensure that when I need it is there. When the demand is there, the energy should be available to supply. So there is another reason why you need a storage. It's not just about the availability of the energy, also to ensure that you have the smooth functioning. The output can be smoothened. For this reason, also storage is crucial. That we call it as a power management. For example, so you get a power operation like this, assume, right? You have a power output, right? Our power requirement is like this, right? Because the power what you get is actually intermittent, so you get the flexible devices available to store also. The point is, there is a variation in the power output from the renewable resources. Whereas if you look at the operation of the industries, offices, corporates, everything, generally they peak between 9 to 5. So the energy requirement from the industry and other things is maximum between 9 a.m. to 5 p.m. And before 9 a.m. and after 5 p.m., generally the energy requirement is actually comes down. Now, to manage this power, can we shave off this peak and shift and distribute such that this bar chart can be made smooth as possible? If I'm able to make this bar chart smooth as possible, I'm able to regulate the frequency. I'm able to match with the output which we get it from the renewable resources. So for this also storage plays a crucial role. So storage plays a crucial role to not only address the intermittency issues related to the renewable resources, also for the power management. For these two reasons, the storage devices are very, very crucial. And what are the storage options available? We have mechanical energy storage, thermochemical energy storage, thermal, chemical, and electrochemical. I'm not going to touch upon any of these. If anybody is interested, probably we can have the conversation later. Out of electrochemical, we have three most important storage or conversion devices: batteries, right? Every one of us carry minimum of 2 batteries these days. One is in the form of a laptop, other one in the form of a mobile phone, right? In fact, most of us also carry additional one, that is in your wristwatch you have a battery. The watch what we wear, maybe just a conventional watch or it could be a smart watch, right? So batteries is become very much part of our life. Probably we cannot live in this earth without a battery. So we have gone to that level of dependency. Then we have the capacitors, right? And fuel cells. Fuel cell is basically a conversion device. A lot of people also classify under storage. In my opinion, it is actually conversion device, right? So I'll be addressing on the capacitors, and I'll be talking about the one of the work done by one of my PhD scholars. This is just to tell you the PhD scholars and the researchers, young researchers who are on board, right? This is the first generation computer. You can see how big it is. It is actually probably bigger than the classrooms, a conventional classroom size, right? And they were able to store the data about 10 MB or so. Now we know that 124 MB comes as a pen drive, right? Thumb drive. You can see that how the size reduction has happened. That size reduction is undoubtedly it's because of the development in the semiconductor industry. It's also because of the development in the energy storage devices. The reason why I say you have the laptop, right? And then mobile phones. All these laptop and mobile phones are powered by the batteries. Without an development in batteries, probably we would not have witnessed the mobile phone or the laptop, right? In fact, the mobile phones, whatever we are actually carrying, is more powerful than the computer which was used for launching the first ever satellite. You can see that you are using more powerful computer in the form of a mobile phone now than what was used to launch a satellite way back, right? Okay, so this is the transition. Now, what is the future? Of course, you guys know this all, right? So the future is wearable electronics. Is that possible, right? and the laptop which can be rolled into a roll top, right? Why do I want to carry a rectangular or square type boxes? Can I roll it and then carry it, right? The future development of flexible wearable electronic devices and roll top is basically depends on the development in the energy sector, energy storage sectors. So there is a huge, what do I say? There is a huge demand for it. There is a huge opportunity also. There is a huge challenge as well, right? So those who are interested to take up, you are most welcome to join and try to work on developing the wearable electronic devices or converting how we can make a flexible energy storage so that when you even roll it, the performance of these devices doesn't go bad, right? That's a big challenge, also an opportunity, right? So having said that, rightly so, the Nobel Prize in the year 2019 is awarded to these three gentlemen who extensively worked on the development of lithium-ion battery, without which the realization of the laptop or mobile phone would not have been possible, right? I had an opportunity to meet all three of them. In fact, with two of them, I in fact spoke to also, with Professor Stanley Whittingham and Akira Yoshirino. I had a personal chat also during tea time. Professor John B. Goodenough is now 97 or 98-year-old. He still goes to the lab every day. You cannot get a better motivation than Professor Goodenough, who is a 98-year-old who walks into the lab every day to perform the reactions, right? So they're all a great source of inspiration for us to work, right? Having discussed about the importance of the energy storage, prior to that, why the clean energy is required, what is our sustainability plan? Right? We live in India. What is India's sustainability plan? India committed to reduce carbon by 25% by 2020. We already crossed 2020, right? This was the sustainability plan drafted in 2015. Okay, right. If you ask me, did we really successful? Yes, but thanks goes to Corona, right? Because of the COVID-19, extensive lockdown and the shutdowning of the industrial sectors, bearing few of them, the carbon emission has largely come down. The transportation sectors were also shut down for several months. Because of that, the carbon actually footprint has decreased. But if you really asked, without which we would not have achieved this, what this says is we had a clear plan, but we really failed in executing that plan. When I say we failed, it includes me and you as well, right? We are responsible for the failure as well. So we are not really as per our plan, okay, right? And this also, the sustainability plan also includes the generation of 175 gigawatt hour of power from the renewable sources, which means that moving from the usage of the fossil fuels and the coal for generation of the electricity to the renewable sources, this 175 basically drops down to 100 from solar, 60 from wind, 10 from small hydro, and 5 from biomass. If you ask me, will we be able to achieve in 2020? We are only 1/4 of the year gone by in 2021, so I don't want to really be very critical on it, but we have a really long way to walk to reach this. Providing 24/7 power in an environmental friendly manner. When you say environmental friendly manner, providing by renewable resources. Right. Again, the question remains slightly unanswered. So we have a long way to go. Right. E-mobility program, every car sold in India from 2030 will be electric. Right. It's a dream. Hopefully we will, dream will come true. So to address all these things, what is crucial? Undoubtedly development of the renewable energy sector. Right. Storage is the major problem in India or in the world, right? If we are able to address the storage problem, renewable energy is not really a big problem, right? And the storage boils down to the choice of the material. So what is the material you are going to use it? That becomes a serious, right? Okay, so having given an introduction, let me move on to the capacitor. That's what I'm going to talk about. You have one hand batteries, the other hand capacitors. Batteries operation is when you supply the electrical energy, that electrical energy is stored as a chemical energy during the charging process. And when you connect the load, the electrical energy stored as a chemical energy is being discharged as a electrical energy. Right? That's how a rechargeable battery operates. Capacitor, it's the same, right? Except one class of capacitor, which I'll talk about a little later. The capacitance is basically calculated by what is the charge stored divided by what is the potential window. Okay, the total charge you store in a capacitor divided by the potential window. And based on the storage mechanism, electrochemical supercapacitor is classified into two major types. One is electric double layer capacitor, other one is pseudo capacitor. The one exception which I said, which is slightly different from the mechanism of batteries, is the electric double layer capacitor. Here, it's a mere absorption desorption of the ions which results in the storage. Whereas in the case of pseudo capacitor, you have an absorption desorption of the ion in the double layer. In addition, there is a redox reaction happening which results in the storage in the case of pseudo capacitors. There are several materials that have been studied over the years, okay, and which can be grouped into three material classes: carbon-based materials, wherein all the starting from the amorphous carbon, activated carbon, carbon nanotubes, all the allotropic forms of carbon, everything comes under this category. Then you have metal oxides, starting with ruthenium dioxide, nickel oxide, manganese oxide, several other transition metal oxides comes into this picture. Then conducting polymers like polyaniline, polypyrrole, all these things. I'm going to focus on the carbonaceous materials in this lecture, right? So each class of the material has its own advantage and disadvantage. I'm not going to talk about in detail about this, okay? Right, I'll just focus on the carbonaceous materials. Those who are interested, we can always discuss later, right? Because I have a class at 11, so I would like to complete that on time, right? So the carbonaceous materials have the ability to charge fast and discharge, especially unfunctionalized carbons. They undergo the charging, discharging by the absorption, desorption process. So the charging and discharging is really fast. So because the charging and discharging is fast, the power associated with that is really high. But the problem is, when the power is high, energy is low, right? And it also uses the corrosive electrolytes. So likewise, each class of materials has its own advantage and disadvantage. Despite of the development of these three classes of materials, the research community is still looking for the new materials that are environmentally friendly. It can be synthesized from the earth-abundant material, so that availability is not an issue to be addressed, and it gives high energy as well as high power, right? So this is an ongoing research which is going on. Our group also contributes a little, very, very little, right? Just like a drop in ocean, we do contribute to the research community, right? Okay, so my focus is on graphene. What is a graphene? You all studied about the graphite. It's basically several layers stacked one above there, right? If you take out one layer of the graphite, that's called graphene. Okay, you have several layers stacked. That stacking is because of the physical attraction between the layers. If you are able to take out one layer from the graphite, it's called graphene. That graphene possesses excellent properties, right? Remember, graphene got a Nobel Prize as well. Okay, right? It has an outstanding chemical stability. The chemical stability of graphene is uncomparable to the chemical stability of graphite. Such an excellent chemical stability it has. Mechanical stability also very high, and it's flexible, unlike graphite. Okay, right? So if I am able to remove one layer from the graphite, it not only improves its mechanical stability, chemical stability, yet it is flexible. I can roll it. Okay, I can fold it, right? Which means that it can go into a flexible devices. It can go into a wearable electronics. It can go into roll tops, right? So it brings out the flexibility. It has got excellent conductivity, right? It possesses a high surface area. The numbers is given for you to witness the high surface area, and it can store a really high capacitance, 550 farads per gram. It can store on either side of the graphene sheet. Okay, but what is the challenge? Challenge is, can I synthesize 1 gram of graphene, right, in an environmentally friendly manner? The answer is, we are not yet there. Okay, right? So synthesizing even 1 gram, forget about the bulk scale, even 1 gram in an environmental manner, in a cost-effective manner, remains a big challenge, right? Okay, so why is it so? It's because of the restacking and agglomeration. So I told you when I discussed about the graphite structure, you have several layers. They are all held together by the physical forces of attraction, right? So when you have a single layer of graphite and several of that single layers, those layers also attract each other. When they attract each other, they will slowly go from graphene to graphite, which means that you are losing all the excellent properties which are listed here, right? That restacking agglomeration is the biggest challenge, which is something which we need to address. So because of this challenge associated with the synthesis and the restacking, what people do is people generally go for a reduced graphene oxide. What is a reduced graphene oxide? You take a graphite, oxidize. So when you oxidize the graphite, you get a graphite oxide. And then graphite oxide is actually exfoliated by ultrasonications and other methods. You get the graphene oxide, then reduce the graphene oxide, you get the reduced graphene oxide. So reduced graphene oxide can be scaled up, okay? And because of the functionalities present, right, the stacking can be reduced. The scaling up problem can be addressed, agglomeration problems can be reduced, right? But the problem with reduced graphene oxide is because of the oxygen-based functionalities you present there, the conductivity is actually compromised. So you lose the conductivity and the surface area is also reduced. So when you compromise on the conductivity and surface area, what would happen to the capacitance? It also decreases. So one hand, you have the problem of synthesizing graphene on a large scale, right? And there is also another problem because it can undergo restacking and challenge. On the other hand, there is an alternate, which you call it as a reduced graphene oxide, wherein you start with the graphite, oxidize into graphite oxide, exfoliate into graphene oxide, and then reduce to get reduced graphene oxide. But in this process, because you are bringing in oxygen-based functionalities, and there is a still possibility of few layered graphene, the surface area decreases, conductivity decreases, so the capacitance value obviously comes down, right? So the problem is, I want a high energy devices for the applications which we discussed in the few slides back, but these reduced graphene oxide don't give that much of energy. If I want to increase the energy density, what is the way? The energy density is nothing but half CV squared. C refers to capacity, V refers to voltage. So you can see here, you can increase the energy density by increasing the capacity or by increasing the voltage. Increasing the capacity is actually the easiest part. Okay, how do I do it? You have a graphene, so you can introduce the spacer material between them. When you introduce the spacer, what would happen? Their agglomeration can be reduced, their restacking can be addressed, so thereby you can increase the capacity, right? Probably you can try to reach as close as possible to the theoretical capacity. Or you can bring in a heteroatom doping, like nitrogen, sulfur, right? So when you dope the graphene with nitrogen, sulfur, the performance also goes up, right? Or you can composite with other classes of materials like metal oxides, conducting polymers. So these are the ways by which you can actually increase the capacity. And increasing the capacity will increase the energy density. But you look at here voltage. If you increase the voltage, it actually squares. The result is a square, V square. You can increase the energy density by enormous way. But it's a difficult path. Why do I say difficult path? When you increase the operating voltage, you need to address the stability of the electrode material as well as the stability of the electrolyte. So stability remains a problem. Okay, right. So we took up both increasing the energy density by increasing capacity as well as voltage. I thought of discussing two important pieces of work carried out by Dr. Bharatdasan. I'll see how far I can go. The first one is we tune the electrolyte because, as I said, tuning the electrode material is conventional way of doing it. So we thought, why don't we tune the electrolyte so that we would try to improve the performance of the reduced graphene oxide. So what we have done is we have added some redox active compounds. By name redox active compounds, don't get carried away. It's just iodide, potassium iodide, sodium iodide, or quinone, benzoquinone, whatever you get it on the benchtop chemicals. These are all very common benchtop chemicals in the chemistry lab. So we have just taken an iodide as well as the quinone and added to the electrolyte and studied the performance improvement because of that. Okay, the first thing actually we need to do is to synthesize the reduced graphene oxide. As I explained a couple of slides back, we synthesize the reduced graphene oxide from the graphite. So then obviously you have to confirm that the graphite is formed. So we have seen through the microscopic image, and the microscopic image confirms that there are few layered graphene. It's not a single layered graphene. Okay, it's a few layered graphene, and also you can see that there are folding, twisting. That's because whenever you adopt a chemical exfoliation method, the method which I described a couple of slides back is called the chemical exfoliation method. That is an exfoliation using chemicals like potassium permanganate and sulfuric acid. You get a lot of defects, folding, twisting, everything happens with the graphene sheets. So that's what you can witness here in these microscopic images. And if you ask me, this folding, twisting, is it good? Answer is yes, because the folding and twisting can avoid the restacking, avoid the agglomeration, which means that you can actually synthesize in a large scale and you don't have to worry about the challenge of restacking and agglomeration, right? And we also confirm by the Raman spectroscopy. So a typical single layer graphene will give only G and 2D band, but if we get D, G and 2D band, this D band is because of the disorders and defects introduced by the chemicals, right? And there are methods by which you quantify what is the number of layers. That is by deconvoluting the D and G band, which is shown here, and the 2D band, which is shown here. So from which we actually find out the ID by IG ratio and the I2D by IG ratio. From the number you get, you can find it out what is the number of layers present. And we found that it's actually more than 5 layers. People accept up to 5 layers as a graphene. If you have up to 5 layers without any functionalities, it is accepted as a graphene. So ours is more than 5 layers. So it's not a graphene. Please remember that it is actually reduced graphene oxide, right? So a lot of people get carried away that reduced graphene oxide is a graphene. No, reduced graphene oxide is actually a chemical exfoliation method by which you synthesize and try to get as close as possible to the graphene. Okay, right? And we examine through the XPS to find it out, is there any doping, because the reducing agent which we used is a hydrogen, which is NH2. You guys know it, or N2H4. So hydrogen is a potential nitrogen dopant. So we explored by the XPS and we see that there is a nitrogen. So nitrogen, it is a nitrogen doped reduced graphene oxide. The presence of nitrogen can also improve the capacitance behavior, right? And we looked at the textural properties in terms of the surface area, and we got the BET surface area of 376 meters square per gram, and BJH surface area, which addresses only the mesopores. BET addresses the micropores, which you see here, a sharp increase at the relative pressure of 0, as well as the mesopores, which you see as a hysteresis loop, whereas BJH only addresses what the surface area due to the mesopores, right? The surface area due to mesopore is very, very critical, because these micropores generally do not contribute to the storage. So we looked at it, and you can see that there is a huge contribution from the mesopore, which is a good news for us, right? Then we looked at it and we studied the mechanism also very carefully, right? So what you see here, the cyclic voltammogram in the black color is the cyclic voltammogram of RGO, reduced graphene oxide, in sulfuric acid electrolyte, right? So you can see here in this area from 0.4 to 0.8, it's a beautiful rectangular shape, which is a criteria for a capacitor. Whereas below 0.4, you can see that there are small hump, right? That's because of the redox reactions happening due to the doped nitrogen and oxygen-based functionalities. When we add the benzoquinone, right, what happens? The moment you add benzoquinone to the sulfuric acid, it becomes hydroquinone, because the acid, which is proton conductor, it absorbs the proton from the acid and becomes a hydroquinone. That hydroquinone undergoes the redox reaction. During the forward cycle, it undergoes oxidation into benzoquinone, right? During the reverse cycle, benzoquinone becomes a hydroquinone. So this peak, whatever you see here, it's because of the transition from hydroquinone to benzoquinone, and then benzoquinone to the hydroquinone. So because of this peak, the capacitance value increases from 100 to 400. You can see that. how much value is increased. It's almost 4 times increase in the storage performance. So we are able to increase the energy by just adding an additive. I did not do anything with the electrode material, right? Neither the positive electrode or negative electrode. What all I have done is I have just added a small pinch, very, very small amount of quinone, okay, right, corresponding to few millimolar concentration. That small amount of quinone which I added is sufficient enough to increase the energy by 4 times. Okay, right? That's what the same thing you witness in the charge discharge cycle, right? So due to the presence of the peak, you get the flat pipe profile, and the rate performance is shown here. What is the rate performance? Just to give you an example with a practical case, most of us now we are using a laptop. So through this lecture, the consumption of the battery is obviously high, right? Sometimes you don't really extensively use your laptop, then the consumption or the energy drawn from the battery is actually less. So you can see that the energy drawn from the battery of the application of your interest is not the steady, it's not the constant throughout. It increases, decreases, right? So what we do is we increase the current drawn from the device and observe what is the change in the performance. In this case, it's a specific capacitance. How does the specific capacitance varies with the drawn current? If it is stable, that's great. Actually, it's good news. In the case of sulfuric acid electrolyte, you can see that when you increase the current from 2 ampere per gram to 10, which is a 5 times increase, it decreases by 35%, which means it retains about 65%. That's a reasonable number. But when we use quinone, though the values are really high, higher than this, you can see that even at 10, it gives you more than 200. Whereas in this case, 10, it comes down to about 70 or so. This value is really high. But the problem is it drops down to 51%, right? That is because of the sluggish kinetics of this. What is a sluggish kinetics? The oxidation of the hydroquinone to benzoquinone and benzoquinone reduction to the hydroquinone. This reaction is sluggish. The rate of this reaction is slow. If you are able to accelerate this reaction, right, then this can actually also be improved, right? So this is one way we have improved. Okay, this slide I will skip because I would like to complete my lecture by 10:45, right? Then the next one, what we have done is we have added the iodide, another bench chemical which you usually find it in the laboratory. So we have added 2 kinds of iodide, sodium iodide and potassium iodide, right? So black color one is again the cyclic volt homogram of RGO, wherein you have the potential dependent variation up to 0.4 and then potential independent variation beyond 0.4, right? When we add sodium iodide or potassium iodide, you can see that there are peaks, okay? Right, in the case of sodium iodide, there are in fact 2 peaks, right, during forward cycle as well as reverse cycle. In the case of potassium iodide, looks like there is only 1 peak, right? And when we looked at the iodine chemistry, so there are 4 possible reactions. Iodide, what you add, can become a triiodide. Very famous reactions, which we also do it at the BSc and the MS level titrations, right? With the help of starch, right? Iodide becomes a triiodide. Then there is also possibility that iodide can become iodine, right? Iodide formed in the first reaction can also become iodine. And iodine formed in the second or third reaction can become IO3 minus, iodate, right? Just like perchlorate, chlorate, it's an iodate, right? So we wanted to understand which reaction happens and which is the most important reaction, which one contributes to the higher storage. And we wanted to understand why potassium iodide gives better performance than sodium iodide. So what we have done is we have recorded the UV visible spectrum of the electrolyte at different state of charge. What is a state of charge? You all look at the mobile battery, right? So you can see that 80% charge, 100% charge, 20% charge. That indicates what is the amount of charge present in the battery. So that is called the state of charge. How much charge is left in the battery to be used, right? So you can see here, irrespective of whether sodium iodide or potassium iodide, okay, at the OCP is open circuit voltage, you have only 1 peak, right? You can see here, only 1 peak in the UV visible spectrum. That peak corresponds to iodide ion, which means that the iodide ion, when you add it, remains an iodide ion. Unlike quinone, it becomes hydroquinone, right? So That's the information we derive from the UV visible spectrum. Right? What happens when I charge to 100%? So you get a peak, and there are a few other peaks. That corresponds to triiodide. Okay, so in the case of sodium iodide also you get the triiodide. In the case of potassium iodide also you get the triiodide. What is interesting is the intensity of the triiodide in potassium iodide is higher than the intensity of triiodide in sodium iodide, which means that potassium iodide conversion of the first reaction, iodide to triiodide, is more feasible. Because of this feasible reaction in potassium iodide gives higher performance than sodium iodide. And also you guys know it. If you have sodium-based electrolyte and potassium-based electrolyte, obviously the ionic conductivity of potassium-based electrolyte is higher than the sodium-based. Something which you must have studied in the third year undergraduate, right? Potassium-based electrolytes always gives higher conductivity, ionic conductivity than sodium and lithium counterparts, right? So because of the higher ionic conductivity, the possibility of this conversion, iodide to triiodide, is high. That's the reason why you get a very nice high intense peak in the case of potassium iodide than sodium iodide. Interestingly, when we enlarged, we saw another peak around 450 nanometer. That corresponds to iodine, and that was present only for sodium iodide, not for potassium iodide. What it means is, in the case of sodium iodide, first reaction happens undoubtedly. In addition, second reaction also happens. Whereas in the case of potassium iodide, only first reaction happens. Second, third, fourth reaction does not happen. Right? And the iodine, obviously you guys know it, compared to iodide, conductivity is less. So in the case of potassium iodide, already potassium iodide ionic conductivity is less than, sodium iodide. In the case of sodium iodide, already ionic conductivity of sodium iodide is less than potassium iodide. In addition, during the reaction, you also have a formation of iodine, which reduces the ionic conductivity further, because of which sodium iodide gives less performance than potassium iodide. So what is the take-home message from this particular piece of work? An addition of a redox active element improves the performance, right? If you add a quinone, it transforms into hydroquinone and then actually undergoes the redox reaction between quinone to hydroquinone and hydroquinone to quinone, because of which we are able to increase the capacitance 4 times. When you add sodium iodide or potassium iodide, the performance increases again. But depending upon whether it's a sodium iodide or potassium iodide, the mechanism is different, right? And I have shown you the rate performance here. You can see that in the case of potassium iodide, the rate performance is very good. It's almost 65%, similar to your sulfuric acid. In the case of sodium iodide, it's actually less. It's because of the poor ionic conductivity, right? Okay, and probably with this, I will just move to the conclusion because of the shortage of the time. I also have a class at 11. Sorry that I have to cut short a little bit, right? What we looked at is, when you have an additives in the electrolyte, the additives can drastically change the self-discharge of the battery or the devices. What is the self-discharge? Let's say you charge your battery to 100% and you remove all the connections, leave the battery, right? It should remain at 100%. But what happens is that it slowly comes down from 100% to 99, 98. That's called self-discharge, discharging on its own. And that discharging on its own is mainly because of the presence of the electrolyte. And if you have some additives, based on what is the nature of the additives, the self-discharge can be high. If the self-discharge is high, which means that battery is discharged on its own without giving the useful electricity, then that's not a good device. So we looked at the self-discharge, and you can see that the black color is for the sulfuric acid. In about 1 hour, the potential from 0.75 it comes down to 0.45, and it decreases slowly afterwards. So 5 hours, you can see that it reaches about 0.4 volt, right? When we add quinone, you can see that in 1 hour it reaches 0.1, which means that when you have the quinone as an additive, the self-discharge is very, very high. Though it improves the performance 4 times, because of the higher self-discharge, actually you cannot use quinone-based additive, because quinone-based additive reduces the conductivity drastically. We measured the conductivity and we have the data as well, right? When you add iodide, you can see that the self-discharge, in fact, less than the sulfuric acid is because the ionic conductivity of sodium iodide and potassium iodide is much higher than the sulfuric acid, right? So self-discharge is really less, right? So what we have done here basically is we have not touched upon the electrode part at all. That's a method by which you can obviously improve the energy density. We have just added some additives to the electrolyte to explore the possibility of improving due to the presence of an additive. When we add quinone, it participates in the redox reaction like quinone to hydroquinone and back to the quinone. That results in the improvement of the energy by 4 times. But that reaction is kinetically slow. Because it's kinetically slow, though the energy is high, power is less, and self-discharge is high. Whereas if you add iodide, which is a bench chemical, sodium iodide or potassium iodide, it participates in the conversion of iodide to triiodide, which is a very fast kinetic reaction. So you are able to get the high energy as well as the high power. But again, based on whether you add sodium iodide or potassium iodide, there is a possibility for the formation of iodine in the case of sodium iodide, which actually hinders the power, right? So what we have done next is probably another 2 minutes. I will just briefly explain. In the previous case, you can look at it. The voltage we could not improve. It remains 0 to 0.75. So what we have done is in the next case, we try to improve the energy as well as power simultaneously, which is a big challenge still for reduced graphene oxide by dispersing metal oxides. That's called nanofluids. So we take the metal oxides, disperse it in the water using the ultrasonification, probe sonification methods. And you guys must have studied about the Brownian motion and the colligative properties. So the particles which are dispersed in the water, they are under random motions. Due to this random motion, they improve the conductivity, thereby we can increase the energy and power. So that's what we have done it. So we synthesized the R2O, right? We confirm the formation. Then what we have done is we have used SiOX and zinc oxide as the metal oxides which were dispersed. So again, what you see black color is actually the cyclic voltammogram of R2O in KOH electrolyte. The reason why we changed to KOH electrolyte is because these metal oxides are not stable in sulfuric acid electrolyte. So we move to the alkaline electrolyte. So it gives a very nice rectangular shape with small hump. That's because of the redox reactions of the oxygen and nitrogen-based functionalities. So when we add SiOX, you can see that we were able to increase the potential window from 0 to 1 to 0 to 1.1. So you can see that clearly there is an increase. And when we go for zinc oxide, it can even go further. You can see that we can go positive direction also to 0.1, negative direction 1.1. So in addition to the improvement in the energy can also be increased by increasing the voltage. Probably this will be evident when I show this graph. So you can see here in KOH, this is the full device, full proper capacitor assembled and tested. So you can see that when you use KOH alone, it gives only a nice rectangular shape from 0 to 1. But when I go for SiOX, it gives 0 to 1.1. And when I use zinc oxide, I can even expand up to 1.2. So you can see that, right? So when we disperse these metal oxides which are dispersed, they are able to move by the random Brownian motion. They not only improve the energy, they also help us in improving the power, which you can witness it in this graph as well. Right, this is called the Ragon plot, which is a plot of energy versus power. So it can improve the energy as well as power. You can see that KOH gives you this sort of graph, whereas SiOX and zinc oxide, they are way up, right? So both energy and power can be improved, and we tested this for 10,000 cycles, and you can see that I can charge and discharge 10,000 times without degradation, right? So just to conclude, sorry, a second part I could not spend too much of time, right, because I have a class next hour, right? So by addition of redox additives, we are able to improve the performance, and depends upon what additives you add. If it is an additive which is organic, which decreases the conductivity, then that's not good. So you look for an additive which can improve the conductivity, and the redox reaction is also very fast. That's the key message from the first paper. And the second work is when you add the metal oxides, due to their random motion, they can improve the conductivity, by which it not only increases the energy, they can also increase the power, right? So that's the message I wanted to pass on. Thank you very much. And this work, as I mentioned, was done by Dr. Bharidasan. You can find him here. Dr. Bharatdasan, who is a former employee of Vivekananda College. And this work was actually funded by SCRB. And these are my collaborators. And thank you all, and wish you all a very sustainable future. I would be happy to take questions if you have any. Thank you. Over
Thank
to
you,
the chair.
sir. Yes. May I audible, sir?
Yes, please.
Yes. Thank you so much, sir. It's really a colorful material expo to the audience community. Once again, thank you. I'm so happy to expect a few questions or maybe some queries from the participant circle connected with this e-lecture by Professor Devraj. Any questions?
Ilayaraja sir, kindly check the chat box.
Yes. Sir, I think Dr. M. Ganapati from Department of Chemistry, he posted 2 questions. Yes, sir. In general, for electrochemical supercapacitor, we get the rectangular shape cyclic autogram, if I'm correct. But sometimes we are getting oxidation and reduction peak in CV for capacitor. Could you explain this?
Yeah, I would probably address with respect to the RGO here. In the case of RGO, probably I'll go to the CV and show. Right. For sulfuric acid, it would be nice. Yeah. So if you look at this graph, I'll go for a full screen and take the laser pointer. So you expect a proper rectangular graph for an ideal capacitor wherein the adsorption-desorption happens. That's the accumulation of the charges at the double layer. But if there is a redox reaction, in this case, you have oxygen-based functionalities. So as I said, it's a reduced graphene oxide. So there are oxygen-based functionalities in terms of the carbonyl, carboxylic acid group, ether, ester, etc., hydroxides. So these functionalities undergoes the fast redox reactions. It's called a fast Faraday reaction. Those fast Faraday reactions give a small hump. They don't really give a peak like this because these reactions are too fast. It's very difficult to pick them up as a very nice peak. So they give the hump. In the case of reduced graphene oxide, in our present work, we also have a nitrogen dopant. And nitrogen dopant, we have 4 different types of nitrogen dopant: a pyridinic oxide, a pyridinic, pyrrolinic, and quaternary nitrogen. And these nitrogen-based dopant also reported to undergo the redox reactions. So because of the redox reactions of oxygen-based functionalities and nitrogen-based functionalities, you tend to see the hump. And the hump, not the peak, is because of the kinetics of the reaction. When the kinetics is very, very fast, you don't generally see a well-resolved peak. You tend to see a hump. So that's the answer. Hope I addressed.
Okay, sir. He also asked one more question. Changing of capacitance value of the particular material with respect to changing of electrolyte is applicable for all the material or only for particular material?
Yes, it is applicable to all. We have to be mindful of the fact that these additives can also undergo the adsorption and desorption. It's a very good question. It's because the quinone or iodide known to undergo the adsorption of the double layer. So if you use a material which is very good for adsorbing, then these ions can adsorb, and on the adsorption, if they block the active sites for the further reaction, then probably they can bring in a negative effect. So we need to actually screen carefully and choose the additives accordingly. So it can be extended for all kinds of capacitor materials, also for the battery material, but we have to be mindful of the possible negative effect too.
Okay, sir. So out of interest, I myself have one question. Now the theoretical world is just moving on graphite. So whether we can improve the capacitance by using these kind of materials theoretically?
Yes, I mean, I'm not good at in theory, but yes, because when you simulate it, I'm not sure whether you simulate with respect to the electrolyte additives also and the concentration. But the answer is yes, we can do that.
Okay, sir. With this, I would like to quote one thing. In ancient epic, icon of Chola's family, King Rajarajan addressed as a very good architecture who had chosen selective material for his historical Shiva temple in Tanjore. Likewise, you are a research architecture. You have been choosing some specific materials like graphene, metal oxide, etc. to build your own research temple. So with this, I'm so much delighted to thank you once again from the bottom of heart. Thank you so much, sir, for your wonderful lecture. Thank you so much.
Thank you, Dr. Ilayaraja, and my thanks to the department head as well as the management for having me here today. Thank you.
Okay, sir. Now I hand over this session to convener Dr. Raghu, sir. Sir, please.
Okay, sir. Okay. Okay, sir. Thank you, sir. Now I would like to invite Mr. A. Dharmanandam, introduce chair 2. Dharmanandam, sir.
Yes, good morning. Yes, sir. Am I audible, sir?
Audible. Okay, sir. Okay, audible. Yes, audible.
Good morning to one and all gathered here for the Enrichment program number 7 hosted by our department. And it's pleasure to introduce the chairperson, the resource person for Sir S. Nehru, Assistant Grade, Department of Physical Chemistry, School of Chemical Sciences, University of Madras, Gindi Campus, Chennai, Tamil Nadu. So this is a trimmed resume of Nehru, sir. Let me read out in a fast manner. He did his BSc from 2004 to 2007 at Gobi Arts and Science College, Gobi Chettipalayam, Tamil Nadu. And he did his MSc from 2007 to 2009 at Madurai Kamraj University, Madurai. And from 2009 to 2010, sir did his B.Ed in Physical Sciences at Government College of Education, Oratanadu, Tanjore. And he did his PhD Junior Research Fellow in School of Chemistry, Bharatidasan University, Tiruchirappalli from 2010 to 2016 under the eminent supervision of Dr. S. Arunachalam, sir. So from 2018 onwards, he is working as assistant professor in University of Madras, Gindi Campus, Chennai. So sir has cleared multiple national level exams during his college days. He has cleared NET LS 2 times in 2009 and 2011, GATE in the year 2010 and NET JRF in 2012. And sir is currently working in a DSP sanctioned project to a tune of rupees 48.2 lakhs. So far he has published 13 papers in highly reputed journals, with the highest being with an impact factor of 7.1 in the journal Sensors and Actuator Biochemical. And sir has delivered an invited talk by National Taipei University of Technology, Taiwan, to favor Taiwan in collaboration in chemical research. Currently, 3 students are pursuing PhD under his guidance in various fields like photo rechargeable batteries, chemical fuels, and high performance. Content of his, any of you want to know about his detailed resume, you can visit his website. So with these words, let me now invite the superstar of this session number 2, Dr. S. Nehru, sir, to deliver his lecture on designing gas sensors for environmental and health monitoring application. Sir, over to you, sir. I will meet you at the end of the session. Thank you so much, sir.
Okay, sir. Thank you, sir, and good morning to everybody. And it's a great pleasure. First of all, initially thank the opportunity given by the Vivekananda College, especially for the principal, head of the department, Shevara Muthu, and convener, Professor Raghu, and finally that coordinator, Dharmanandam. To all, first of all, initially I thank. Is it audible to all of you?
Yes, sir, it is clearly audible. You can proceed.
Yes,
sir.
Okay, very good. Is it clear to you? Is it clearly visible? Professor?
Yes, sir.
Is it visible to you?
Yes, sir.
Okay.
Yes, sir. Yes.
Okay.
Perfect, sir.
Okay.
Steve.
Okay. So after the first grade session in the area of supercapacitor energy storage devices in the topic, Then another one important topics in the area of especially like physics and chemistry, interdisciplinary research oriented area, because we know the word gas sensor, mostly we hear about that word gas sensors, and mostly like because usually we are seeing that gas sensors like the traffic police, whether the person is drink and drive, and like whether he took any alcohol content, like that can be monitored by the gas sensor device. So like that, so it is a well-known instrument. So the based on the concept of the gas sensors, so not only that, ethanol gas sensors we know. So there are several, for example, environmental related issues in the world, and similarly health related issues. So how the opportunity we have to detect the sensors for the determination of the concentration of any environmental polluting gases or health related gases, like that it is an ambition to design the gas sensors for the different wide areas of research. So this is our Madras University campus, Ginti campus, nearer to the CLRI and IIT Madras and Anna University. And this is the building our laboratory is there. And in this building, third floor, our lab is there. And one of the thing, basically, that one of the well-known incident, like in 1984, a Bhopal gas tragedy that was happened. That was the world one of the biggest gas leakage accident. So that is the very worst thing. So that was happened due to the leakage of gases. So definitely, if you want to avoid that kind of gas leakage or that kind of accidents, means if you have any accessories or any monitoring unit like a gas sensors to detect whether any leakage of gases is there in the industrial purpose, means it can be avoided. Similarly, another one is in 1984, like in Mexico, that was due to the LPG gas leakage. Due to that, fire explosion has happened. So in those cases also, because nowadays it is possible with the detection and monitoring the LPG gas detection by using the different varieties of gas sensors. So even in early cases, that was missed due to the that unknown factor of that gas sensor exploration research. And similarly, in the case of Visakhapatnam area also, there was some mysterious gas like petroleum-related gases that has been released to the environment. So that also huge disaster, that industrial disaster also happened. So for these are some of the examples in day-to-day life because of the gases-related environmental and health-related issues that happen in everywhere. And another one basic thing and thing we are seeing in day-to-day life, because usually we are getting some news like Visavayu Taki இறந்து விட்டார்கள் அப்படின்னு சொல்லிட்டு நம்ம இதில் பார்த்துருப்போம், டிவி நியூஸ்ல பார்த்துருப்பாங்க. when the sewage cleaning, that kind of process is going. ஸோ அப்போ என்ன பண்றாங்க, விசவாயு தாக்கி இறந்துட்டாங்க அப்படிங்கிற ஒரு நியூஸ் ஆல்வேஸ் we are hearing. So nearly for example yearly around 340 people are died due to this kind of septic tank that poisonous gas. Okay, so if we have any provision to detect that poisonous gas level or that presence in that sewage area, means so we can avoid the death due to that poisonous gas. So definitely some of peoples are developing towards for example the gas like H2S gas, maybe the poisonous gas present in the sewage. So people now are working in developing the device to detect that H2S level in the sewage areas. And so based on this industrial problem as well as personal problem, so definitely we need a simple and best solution for monitoring this kind of gases in day-to-day life. So for example, because you know that the Panchabhudam, in Panchabhuta, one of the Bhuta is gas. So in these things, so world is consists of the gas like hydrogen, nitrogen, oxygen, and carbon monoxide in many gases. Even industries also using that gases, and the industries also releasing the some of the gases, and transport vehicles, they also releasing the gases. So that this kind of continuous releasing of this kind of gases, like especially organic volatile organic compounds gases, so that environmental pollution is happen. Like because you know that whatever the any chemical compound, after a certain concentration, that is the minimum, after a minimum concentration of exposure, then it will induce the some toxic effects in human body. Not only human, and also it also do to toxic to the any living things like trees or whatever may be in the world. Okay, so that it is an important and emergent thing to monitor the that gas levels in the earth, or as well as in the case of several diverse applications. For example, some of the industries also processing the gas related that equipments, so that suppose in those industries there will be a continuous flowing of gases. So those cases means we need to continuously monitor the how much gas is input and how much gas is output, and what is the flow rate. All these things we have to follow it. So to follow that thing means we need a simple and best solution like a gas sensor for specific any particular gas monitoring application. Even environmental monitoring application. So environmental, we know because Tamil Nadu Pollution Control Board, they usually monitoring the how much quantity of toxic gases or pollutants in the air, that is every day it is exposing. So that we need but that they are usually monitoring the levels using the gas chromatography, like a GC instrument, for the how much pollutants is present in the air level. So that because that is the that is the costliest one, because that environmental monitoring system only will be in the metro cities and main cities, but it could not very much monitor in the all the areas of the Tamil Nadu. So that we need a cheap solution to monitor that toxic gases, toxic pollutants in the environment. So that the alternative to that gas chromatography, we need a simple solution like a gas sensor, like a minimum budget gas sensor device. That may be like come around 1,000 or 2,000 like that. So by using that, we can monitor the that any pollutants in the environment. And boiler control, because industries also they following the boiler gas based boilers, means there also we need to monitor the concentration of gases and the fire detection. Even in several whatever the big floor buildings or any industries, there we have a fire detection device. So that based on the gas sensor, that are working are based on the principle of that gas sensor. So that fire, if any fire happen, means immediately that gas sensor will detect that smoke level, then it will indicate alarm. Okay. Then alcohol breath test, as I told already, traffic police, they use that alcohol breath analyzer. So if any person took a certain amount of alcohol, means it will detect based on that ethanol gas levels. So this also an thing we are using in day-to-day life. And detection of harmful gases in mines, because we know mines because mines are being in the underground, right? So there will be a lot of gases like several poisonous gas, methane, ethane, or H2S, like many gases may come from the mines. So that it is very important, because there and all means you could not directly monitor because that mines and all means there will be work happen maybe in earth like 1,000 feet below or 2,000 feet below. So there and all you could not continuously monitor the any toxic gases levels in the mines. So that if we have a gas sensor device like a simple low cost device, means so we can use these kind of devices at the level of that mines, so that we can continuously monitor any gases, poisonous gases in the mines. And even you don't know or whether we aware about the that home safety, because in the foreign countries and all means they compulsory they used to have the gas sensor, like especially like LPG gas sensor, because if whether any gas leakage due to the LPG gases is there means, then immediately it will detect. Whether any smoke sensor like a fire detection sensor, like any fire is there, firing happen means, then immediately it will detect the smoke level in the home, and then immediately transfer that data to the main city. So like that, what we call that smart city, like that. So for building this kind of smart city means, definitely it is a need for this kind of different kinds of gas sensor. Even in coffee productions, agro products like coffee and spices, they will release some gases like a small gassing gases, so that if you monitor that smell level, so we can also grade the what is the quality of coffee, these things. So this is a small introduction. Let me go to the how to design the how to explore the research area in the area of gas sensor devices. It is a simple thing, but it's an important and challenging one. And only a little bit researchers are working in the area of this kind of gas sensor all over the India. So even though some of the gas sensor devices like small gas sensor devices for the detection of ethanol, methanol, benzene, toluene, these kind of things is available in market, but they are not very much sensitive and selective to the detection of that particular and specific gases. So that is the problem is really existing. And as a chemist research, we need to give a solution to explore the this kind of gas sensor, particularly with the property of sensitive nature as well as selective nature against the different kinds of gases, like any poisonous gases, like even carbon monoxide or ethanol or methanol, acetone, toluene, benzene, whatever the gases. So we need to specifically design a material, and we need to specifically design the device to detect any particular gases. Then only that device will be economically and commercially viable. So in this kind of gas sensor device fabrication, one of the thing is metal oxide based gas sensors, particularly that has the resistance based detection, because if you monitor the resistance simply by using the multimeter, because multimeter, just the basic change in resistance can be monitored by the multimeter, whereas if you monitor the gas levels with respect to gas chromatography means, that will come around the 10 lakhs of budget, because one gas chromatography instrument that they cost. Whereas if you have the gas sensor device with the multimeter connection, like the principle of device means, even you can monitor the toxic and poison gases even within the budget of 2,000 or 5,000, like that. So it will be a best option for monitoring, even for the continuous monitoring, even for the gas chromatography and all means, you need to collect this sample and inject manually to the instrument and get the data. So you could not continuously monitor the poisonous gas or toxic gases in the environment. So that what is need means, we need a continuous monitoring system, and that can be possible by using this kind of gas sensor devices. So in our area of research, we particularly focusing our research based on the chemi-resistive, because the materials, materials, they has the resistance and the conductance property. So based on the material, suppose if you take any material means, that material has a specific resistance nature. When any toxic gases or any gases absorbed on the surface of that material means, then there will be a change in resistance will happen by based on that amount of absorption of toxic gases or any gases. So how much level of change in resistance happen in that metal oxides. Based on this simple principle, we can follow the the concentration of gases in the environment, even because I already told one more thing also, health applications also we can use this gas sensor device. In how means, because the diabetes is one of the major problem, and most of the even middle aged persons are suffering with the diabetics. So that, because if you want to test the diabetics level means, every time you have to make the pinch the using the blood level. So blood glucose level you have to monitor by pinching pinching with any pin and collect the blood, and then you can monitor the level. So even for one time and two time means you can pin the your blood level, collect the blood level. Whereas for the continuous, for daily you are taking for the two times or three times, or for a yearly, for all the days you are collecting the blood glucose level means every time you need to collect the blood. So it is a painful process. So what is the solution for this kind of diabetics monitoring means, we can go for the non-invasive method. So non-invasive method means like so without painless method. So because one of the biomarker, for example, diabetics patients, they has the glucose level. So diabetics patients, due to that metabolism activity and nature, they will release, when the diabetics patients will release the acetone level, excess of acetone level compared to normal human being, because every human being will release acetone gas, even toluene gas or benzene gas, whatever, because they will be in very ppb, like parts per billion, like of that kind of concentration level. So for the, especially for the people who having the diabetic suffering means, they will release acetone level particularly above the normal human level, normal. Okay, so for those cases means, you need to, if you have the option for the acetone gas sensor device, that monitoring the acetone level in your breath means, so that is a painless process as well as simple process. Even in the budget of 2000, you can make the device to continuously, even many times you can monitor, so that continuous monitoring of acetone level in breath. So like so that we call this as a breath analyzer or e-nose. So normally in, nose, then e-nose means electronic nose. So electronic nose means, so electronically a gas sensor that will detect that any gases concentration like our human nose. So that we call as a e-nose. So this gas sensor device also we call as a e-nose. So for the diabetic patients means, they will excess amount of acetone they will release due to the metabolic reactions. And similarly, even in breast cancer, even breast cancer patients, they will release the toluene. So from their lungs also they will release the toluene gas. So normal human, even a normal human maybe has the very low parts per billion of quantity of toluene, whereas the breast cancer patients means, they, due to some metabolic reactions, they will release the toluene gases. So if you have a provision to detect the toluene level from your lungs exhaling, so that you can monitor, or whether you have a option, whether you have any possibility for affecting with the lung cancer. So yearly detection of that lung cancer and breast cancer, even that also possible by using the developing the toluene gas sensor devices. So with this importance in the area of environmental issues, as well as for the health related applications also, these gas sensor devices and gas sensor material development has the prominent research area for developing diverse applications, even for the commercial level. So as I told already, so this is a simple gas sensor device. So just like you can see, so you can see here, like a ceramic substrate will be there. In this ceramic substrate, Ag electrode, silver electrode like will be coated. On this coated surface, metal oxide like silver, bismuth oxide, any metal oxide can be coated on this area, and then it shows it. Then this will be keep in the container which has a provision for gas inlet process and gas outlet process, and this is the chamber, and this chamber, gas chamber, this material, this positive and negative, this side will be connected with the some multimeter, like even if you have the Keithley source meter, power source meter, means you can measure the change in resistance, like how many ohm, whether it is in the ohm range or milli ohm range or mega ohm range. So how much level of resistance change with respect to absorption of any external gases, that can be monitored by using this kind of simple device fabrication. So as I told, for the gas sensor applications, first we will choose the materials, what kind of metal oxides have the, because we know that band gap, that kind of many properties, because that absorption properties as well as that conductance, resistance, electrical properties, all depends on that structure, that crystal nature, and all the things that the phase, all the things depend. So that first we have to carefully select choose the metal oxides, and then we have to synthesize that material. Then we need to characterize the metal oxides using the different methods. For example, you need to first structural characterization, like because that nanomaterial XRD, UVDRS, like that optical properties, then IR characterization, even that morphological characterization by using the same instrument, EDOX techniques, STEM techniques. So after these characterization techniques is over, then we will do that gas sensor studies. So in these gas sensor studies, we will do or monitor the several parameters like response. So response, that change in resistance with respect to that air as well as in the presence of gas level. So that sensor resistance and sensitivity, like with respect to initial resistance, how much level of change in resistance happen in the presence of gas, that will be monitored by the sensitivity term. And repeatability, whether the gas sensor device giving repeatability of results for the 1 or 2 times or 3 times or 5 times of results. And stability, so how long it is stable, whether the gas sensor device continuously stable for 1 day or 3 day or 30 day or 1 year, that stability period. Then response and recovery, in how fast our gas sensor response give the response as well as recovery, right? Once the gas is outletted, means then how much time is needed to recover the original resistance stage. And humidity, because gas sensor will be affected with respect to humidity levels in the atmosphere. So how that humidity will play on that gas sensor. And sensor response, like how the response with respect to sensor material, that and all we also discuss, and we will monitor. And then resistance of the gas sensor and response of the gas sensor, all the parameters we have to carefully monitor for designing the clear and the effective materials for the gas sensor applications. As I already explained, this is a gas sensor device, and gas sensor response. Gas sensor response can be calculated, because RA, resistance of the gas sensor device in air, and gas sensor resistance of the material in the presence of gas. So that by using this formula, gas sensor response you can calculate. And gas sensor response, so that can be RA minus RG divided by RA into 100. So in percentage term, we can calculate or express the gas sensor response. And sensitivity means response, the response value divided by at what concentration, to the any specific concentration, how much of response is getting. So by using that, we can get the data for the sensitivity. These are the 3 important parameters we will follow for the gas sensor applications. Then, as I told already, the choice of materials for the gas sensor application is an important thing. So the criteria like gas sensor response, sensitivity, that response and recovery time, selectivity, whether your gas is selectively detect ethanol or methanol or acetone or toluene or whatever, whether what is the selectivity or interference studies, and then sensing temperature, whether the temperature will affect the that sensor response and sensitivity values and stability. These are the things we have to carefully monitor for the complete analysis of gas sensor studies. And then efficient ways to enhance the sensor response, because even though several materials or several metal oxides is available, even little bit of gas sensor study is available with the systems. Even if you take the commercial gas sensor devices, they has they mainly made up of like tin oxide, ruthenium oxide, or zinc oxide. These are the main some of the material commercially available for the gas sensor applications. Only drawback, as I already told, it has that the selectivity and the sensitivity problem. So that we need to solve that sensitivity and the selectivity problem of commercially available that gas sensor device. So what we can do mean we can fine tune that material by using the different strategies, like we can dope the any metal or metal oxides composite formation, or noble metal nanoparticles, or even carbon based material like a graphite carbon nitride, or a nanotube, or graphene. Like these kind of materials we can add with the tin oxide or zinc oxide, or even we can do the sometimes UV activation like external light source, so that we can optically tune that band gap, so that gas sensing phenomena also we can fine tune. So this is let me go to this basic introduction about the gas sensor and the era about that one. Let me move to our work on the gas sensor device fabrication and development in these things. And recently at 2020, right? Sorry, 2021. We have published this room temperature operable high sensitivity toluene gas sensor using chemi-resistive silver bismuth oxide based nanocomposite. So, as I told already, this toluene gas is the cause for it is a biomarker for the breast cancer level. So, if we have succeed in the very selective toluene gas sensor device fabrication means, so that can be used for monitoring that breast cancer level, even for the lung cancer level, for the biomedical applications. So towards the goal we are working. So even commercial gas sensor devices, if you take it, means they usually working working at a specific high temperature like 100 or 200 degrees Celsius ranges. So that what we are tried means we tried to develop the room temperature operable gas sensor device, so that the sensor device will the stability of the sensor device under the high temperature will be low. So to avoid that stability of the gas sensor devices at the high temperature operation, so we have focused on the room temperature operable gas sensor device fabrication like that. And we have chosen bismuth oxide is a very very good semiconductor material for the gas sensor application. So silver, silver is a metallic silver also has the very good optical and electrical properties. So that we tried with the silver doping in the bismuth oxide nano material and prepared the nano composite, and that material have been used for the toluene gas sensor, toluene gas detection. Particularly because you could not predict whether your material is whether we are not specifically focusing for toluene gas, because we are taking the material and we are trying with different gases. So based on the outcome of which gas has the high sensitivity towards the nano material, then thereafter we will fine tune the material towards that specific gas. So this is the one of the paper sensors and actuators B chemical science direct. This is we have published. So the basic thing here, so before this going to the gas sensor and related research oriented things, then the synthesis aspects of nanomaterial, like we took the bismuth oxide and silver doped bismuth oxide. So that can be because the synthesis of nanomaterial, because here you can see here, because the gas sensor working in the principle of that absorption and desorption process, so that absorption and desorption process definitely will depend, it depends on the that structural and morphological and optical and electrical characteristics of the solid materials. If you fine tune the that material in different synthesis methods, then you can achieve the selectivity and the sensitivity against the any gases. So it is an very toughest project, like it is a trial and error project, so that we have to continuously modify with the different approaches, different strategies, so that definitely we could able to achieve the gas sensor device against any specific gases detections. So here we have followed, here is a hydrothermal method. So in this method, just like a bismuth nitrate, because a source for the bismuth oxide is bismuth nitrate. So just a bismuth nitrate in the dilute nitric acid, then it was chilled for the 30 minutes at the 25 degrees Celsius. And then we add the stabilizing agent like polyethylene glycol, because it will reduce the agglomeration of nanomaterials. So that we add polyethylene glycol, and then we have adjusted the pH of the medium using the sodium hydroxide. Then the resulting mixer was aged for the hydrothermally, that using the autoclave. We have aged for the 3 hours, and then the final product was collected, and that was clearly washed with water and absolute ethanol repeatedly for 3 times. And then that final product was dried at 90 degrees Celsius for 24 hours. Then finally, again, we are annealing that precipitate for the 500 degrees Celsius for 4 hours. So this is the preparation of bismuth oxide nanomaterial for hydrothermal. So like this also you can tune the different, because you see here we are taking the bismuth nitrate material, nitric acid, and the polyethylene glycol and the sodium hydroxide, and that temperature changing, and that annealing temperature changing, and the aging temperature, aging hours, and that stirring hours. These are like these kind of several synthetic strategies and synthesis approaches. You have to trial and error method, you have to work it, so that you can tune the size of the material, that the size of the nanoparticles or structure of the nanoparticles, or that electrical and optical these kind of properties you can fine tune by changing the ratio and ratio of the components and timing, all these things. So we have followed this method. And similarly, because for the silver doping, so after the in the addition to this bismuth nitrate, we added that silver nitrate as a precursor, because this silver nitrate will be reduced by this polyethylene glycol as a reducing agent, so that we are getting the silver doped bismuth oxide. So like that, so whenever it's like a simple example for the synthesis of bismuth oxide and silver based bismuth oxide. So you can follow different many methods, like hydrothermal method, simple heating, just a simple thermal method, a simple mechanical stirring, mechanical stirring, or even you can use the different instrument, even magnetic stirrer, or like the different applications, even like a probe, ultrasonic probe based synthesis. This kind of different synthesis method is available. So each one has the different application and different influence on the absorption and desorption properties of the gases on the surface of the material. So that you have to carefully do all these things in mind, and you have to work it with that system. So once the material is synthesized, it means Then the material is characterized and by using the different methods for the structural, morphological, optical, and electrical applications. Then next we move to the measurement of that sensitivity of that gas sensor material against the different materials. So as I shown already that gas sensor device, how we have fabricated the device and how we are monitoring the experiment, that all we have told already. So here also a ceramic substrate. On that ceramic substrate, silver, one ceramic substrate we take. On that substrate we coat the silver wire and silver electrode configuration. On that silver configuration we coat this our metal oxide material, and that material will connected to the like a digital probe, digital source meter, like a Keithley source meter, so that changing. So in air atmosphere, how that material showing the resistance value, and in the presence of the gas, external gases, how the change in resistance happens. All the things we have followed. So as I told, once the material is synthesized, it means then we are characterizing the material using the different because solid nanomaterials mean definitely you need to go for the powder XRD, so that what is the composition and what is the structure and morphology structure of the and face of the crystal lattice that you can monitor by using the powder XRD pattern. So that what are the phases and what are the new peaks, whether any new peaks is observed, what is the any change in intensity of the peaks is observed in the XRD, so that you can identify the morphological change or crystalline changes in the prepared nanomaterials. Because here you can see here, because we are doping the silver, so whether the silver is present in the form of silver ion form or metallic form, so that can be seen by using the presence of silver peaks in the according to the JCPDS number of 040783, so which corresponds to the diffraction planes of the silver in the metallic form. So just we have to always carefully analyze the material and compare the material with the initial and after the doping. Then you can analyze the what is the change in the structural properties. Then another one thing is instrument is FT here, because change in vibrational frequencies, because the bismuth oxide means bismuth and oxygen bonding. There will be a bismuth oxygen bonding, and once if you are adding the silver means whether any change in the frequencies of BIO stretching frequencies. And another one, we are also adding the polyethylene glycol. What is the any corresponding peaks with respect to for the polyethylene glycol, and what is the change in the peak of the BIO frequency, because you can see 540. At the 540, this peak is corresponds to the BI stretching frequency. So when this is adding, when the after the doping process is over, then the peak is this peak has been shifted to the, I think, 620. Okay, so 620 peak. So this indicates that how much change in the crystalline vibrational frequency can be monitored by using this technique. And another one, this is because that resistance and the electrical properties. Electrical properties, it depends on the depends on the band gap. Band gap, valence band and conduction band energy. So based on the conduction band and valence band energy, band gap energy, so we need to find out the what is the change in band gap energy, or what is the band gap positions. All these things can be get from the UV DRS analysis. Okay, so initially you can see that for the 2.79 electron volt for the bismuth oxide band gap, that was decreased by the adding the Ag. That means the band gap decreases means that EC, that conductance will be increases, or that will be conductivity increases and the resistivity decreases. So that when you 2.79 and 2.71 silver doped bismuth oxide means, then that change in the band gap positions and the things can be monitored by using this one. And that band gap was calculated by using this tau plot. So from this tau plot you can get the band gap energy. Then once the structural characterization is over, then we need, because the surface morphology is also important, because absorption disruption is depends on the surface morphology. So here you see here surface, what kind of surface morphology happened in the present below bismuth oxide alone and silver doped bismuth oxide alone. So just you can see this is like a simple aggregated A. Figure A for the bismuth oxide, that corresponds to that appear like a nano rod, like aggregated nano rods, whereas silver doped bismuth oxide, that shows the nano capsules, like big capsules, nano capsules like images. So just it's giving the what is the size and surface morphology of the material changed in the presence, and in the prepared materials can be monitored. And once the surface and these kind of properties, that properties have been characterized, then definitely let me go for the gas sensor studies, because we don't know whether our material is going to detect the one gas or two gas or multiple gases. We don't know. So generally gases like hydrogen, nitrogen, or whatever the many gases is, for the gas sensor for these kind of gases is available. Whereas for the volatile organic compounds, volatile organic compounds mean easily evaporatable organic gas molecules. So like ethanol, methanol, formaldehyde, acetone, benzene, toluene. So these kind of volatile organic compounds, they are continuously released to the environment through the day-to-day life or industrial process or even transport. Like these kind of things is continuously released. So that the continuous monitoring of this level, continuous and sensitive and selective monitoring of these kind of volatile organic compounds in commercial level is lack. So that we are interested to focus on our research towards development of gas sensor device for these kind of volatile organic compounds detection. So that initially what we did means, we taking the different gases like this kind of volatile organic compounds, and the sensitivity, that gas sensor response have been calculated in the presence and the absence of that gases. So that, as I told already, they're using that formula, then we are getting the 89.2% for the silver, because in all the cases you can see red color corresponds to the that bismuth oxide alone, that bare bismuth oxide. Whereas when you are adding the or doping the silver into this bismuth oxide, that gas sensor response is extensively increased to the high level. So you can understand that the importance of the that composition making as an important role in playing or in developing the gas sensor device. So that, as I told, it is a trial and error example, so that we need to do several attempts for getting the sensitive and selective detection of particular gases. So in our work, we have found that the toluene gas compared to other gases is more selectively detected. So even this is around normally for the bismuth oxide alone means it shows the only 15%, whereas when you are doping the silver, then it will really accentuate to this 90, around 90%. So that we are selected this toluene material, and we extensively studied that as I told already, the parameters, gas sensor parameters that we have calculated for these toluene gases. And this method, actually, can I tell how long time is present, sir? Sir, excuse me. Hello. Sir, is it audible? Oh, okay,
Yes,
okay.
yes, sir.
How long time I can
Sir?
take it further?
Sir, 10 minutes, sir.
10 minutes. Okay, 11:45. Is it, sir?
Yes, yes, sir.
Okay, okay, okay.
Okay, sir.
Okay. Because of the time constraint,
Okay, sir.
just I will go fastly. Okay.
Yeah,
So the
okay,
basic phenomena. Okay, the basic phenomena in the chemical aspects, chemical mechanism, behavior. That how that happen. If you understand means, then on next. Hello. No. Please. So the basic, the change in chemical resistance behavior, you can be explained with respect to the mechanism of this behavior. Normally, this is the metal oxide. You see here, this is the metal oxide. This has the this has the an effective conducting layer or conducting region. When you expose this metal oxide to the oxygen means, then this oxygen will absorbed on the surface of the this metal oxide. So that what will happen means, this absorbed oxygen will extract electron from this conducting layer, that the conduction band of the metal oxide. So it will extract the electron from the conduction band of the metal oxide. So once the electrons extracted from this conductant band of the metal oxide, there will be a depletion layer will be formed around this metal oxide. You can see this is a complete brown, whereas here is brown with the dusty, just sandal colored region is there. So this may be this region is saying that it is an electron depletion layer. Why this electron depletion layer happen means, because the electrons in the conduction band of that metal oxide has been extracted by the absorbed oxygen molecule. So that this electron depletion layer formation, this resistance of the material will decreases, because this has initially it has some resistance value. Once you expose this material to the oxygen environment, then resistance value will decreases. Then again, when you are adding the any volatile organic compounds means, then these volatile organic compounds get these electrons from this oxygen. So these volatile organic compounds get the electron from this oxygen. So that what will happen? This oxygen again will release the electrons to this metal oxide. So that means this electron again come back to that metal oxide. So that this electron depletion layer region will be decreased. So you can see here that the electron depletion region has been decreased due to this displacement of this absorption, this volatile organic compounds absorbed on the surface of the metal oxide. So that phenomena, this electron will be again come back to the metal oxide. So that depletion region will be decreases. So once it decreases means, then resistance will be also decreases. So based on the oxidation behavior and reduction behavior of that gases, this gas sensing mechanism may be varied. So just you may understand how that involvement of that oxygen and electron depletion layer formation, that electron depletion layer shrinkage and exposure. So all the things you may study later. So this is a simple experimental data for the analysis of the bismuth change in resistance, as I told. So this is the initial material. So just you can see here, this is the resistance of the blue color. That is, it is like bismuth silver bismuth oxide material. They has the initially they has the some resistance property. When you are adding the 50 ppm of toluene gases means then that resistance value immediately suddenly decreases. That means that response is very good response. So effectively decreases to a particular level. Thereafter it will be like a small change only. So after that long time only a small change in resistance. Then again that recovery, as I told, response time means inlet of gas and recovery time means exposing of that gas, so that the recovery. So once you open up the chamber, then that will be compared to this response, that recovery may be slow, but it will completely, mostly completely come out of that all the material, that all the absorbed gases will exposed away. So that this is the response and recovery timing can be compared. And similarly for the different ppm of gas. So because you know the ppm, parts per million range, so we did the same kind of resistance change for the 10 ppm, 20 ppm, 30, 40, 40, 50, 60, 70, 80, 90 and up to 100 ppm we did. So that the change in resistance with respect to applied toluene gas, so that can be studied. So once we get it, this means, so we are getting the information that our gas sensor material is linearly its response with the toluene gas. So once that resistance value have been shown, as I told already, that RA by RG. So this RA by RG versus time. So if you do, so the resistance in air and the RG is the resistance in gas. So by using that, you can clearly see that there will be a linear increase in the response value with respect to change in the concentration of the toluene gas. So this you can get it. Then this RA by RG value with respect to concentration ppm. So with respect to this, we are getting a very good linear straight line for the whole range of gas sensor studies. So with these things, so we can get the value of that sensitivity value. So that sensitivity, so the sensitivity for the silver bismuth oxide, it's like a even 0.129. So for this case, 0.129 ppm per ppm of sensitivity, whereas bismuth oxide that shows the only a 0.002 ppm per ppm of sensitivity. So if you analyze the data, just it's like you just understand what is the how we are analyzing the data. That's even though we are taking one data, and first we did for the resistance change and response study and the sensitivity studies. Then compared to literature, so several materials, like even you can see here several around 27 materials 27 materials of nanomaterials, that corresponding response values and corresponding operating temperature value and concentration range value you can see here. So in our material shows the 50 ppm, even 50 ppm of low concentration, and the room temperature, because you see here only little bit, only 5 or 6 material has the room temperature operatable work. But even those material, they has the even that response value maybe like only little bit, whereas our case we have the very good response value. Compared to this value, we have the high response value under the room temperature operation conditions. So compared in literature, we have the very good high response material for the toluene gas detection. So as I told already, that repeatability study and repeatability studies and the stability studies and the stability of the resistance for the different duration of time, and then response and recovery time for the each concentration. What is the change in response timing and the recovery timing? So this all data you can get it. So here you can see for the resistance response for the continuous 5 cycle. So there is only a little bit change in the response for the continuous 5 cycle, and again the change in resistance for the silver bismuth oxide for the prolonged period time, there will be a little acceleration in the values. And similarly for the comparatively for the stability for the like different continuously for the around 1 hour or 2 hour of timing, it is a very only a little bit change in the resistance values. And the response value, as I told, response and recovery time for the each concentration have been plotted here. And you can see here recovery time. So recovery time is increases for the recovery time is high for the high for the all the concentration materials, whereas only low response values. That means our system has the very good response value, and the recovery value is low compared to this timing. So as I told already that humidity value is also an important thing. So when the change in humidity, how the response and resistance value changes with respect to that humidity, that we have, that also we have studied. And then response value with respect to the humidity, that also we have studied. So these are the things we can, if you analyze means, then you can get it the quality and the sensitivity and selectivity of the material for the different gases. Okay, so it is like a continuous trial and error research method. So we can attempt with the different methodologies, different approaches, different gases, so that we can achieve a best material with the with high sensitivity and high selectivity. And just I stopped with this slide, but just I show material. We have also developed a GC3 and 4 zinc oxide based material that also we have published, and that has been published in Material Advances RSC. That showed that showed a response against response for the formaldehyde system, but synthesis and the structural characterization, UV DRS and surface morphology, gas sensor studies, and then comparative table and the gas sensor studies, resistance response, and that repeatability, stability studies, all the things. Okay, so finally I conclude with the in future definitely there may be a possible with the wearable gas sensor devices may in future may come, like that gas sensor device may come with the eyes, that glasses or helmet or just wristwatch, like even shoe or mobile phone, hand gloves, like this kind of. In future it may be happen. So because a smart world and smart cities development and wearable gas sensor device monitoring and health monitoring and environmental monitoring application, so we can work towards this kind of achievement. And finally I thank my research scholars and Madras University and the project DST said project for sponsoring this work. Thank you. If any questions is being means, you can ask.
Yes, sir. Thank you. Thank you
Okay, sir.
so much for a wonderful presentation, sir. It was awesome, right from the first Colorful and sensory.
Thank you, sir. Thank you, sir. Something voice is yes. Okay, sir. Thank you.
Ilayaraja, sir.
Sir, tell me, sir.
Yes,
sir.
sir. Okay,
Is
okay,
there
sir.
any practical difficulty to sense the carbon dioxide, right? So
Yes,
carbon
sir.
dioxide, okay, actually a carbon dioxide gas sensor is many is available for the commercial level, I think so. So there is no difficulty, I think, to monitor the carbon dioxide gas sensor levels.
Okay, sir.
But we need to specifically design the material. We need to optimize the synthesis and structural, optical, that all the properties of the material, so that we can specifically tune the sensitivity and selectivity. The only thing is the practical difficulty in the gas sensor field is only thing is sensitivity and selectivity. Even though whatever the commercial level carbon dioxide material, carbon dioxide gas sensor is available in market, but definitely there will be a slight lag in the sensitivity and selectivity. So that and all means we have to overcome.
Okay, sir. Okay, sir. Fine.
Okay, sir.
Yes, sir. I have
Okay.
few is my voice
So, Dharma, your
audible?
voice is not audible. It's splitting, I think so. Dharma, can you check your voice? Dharma, are you there?
Sir, Ilayaraja, sir.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Okay, sir. Okay, sir.
Okay, sir. Thank you.
கேக்குதா?
Sir, sir, shall I leave?
I think some technical problem here from
Yes, yes, they're audible.
Thank you, sir.
Okay,
Sir,
okay.
next. Okay, sir. Sir, Dharmana, sir. Sir.
I hope there is a technical snag. Audible?
Thank you, sir. Now I would like to invite Dr. S. Ilayaraja, sir, introduce resource persons.
Thank you, Raghu, sir. May
Sir,
I
audible, sir?
Okay, sir. Fine.
Okay,
So
okay, sir. Yes, sir. Audible.
Okay, sir. It's a great day again to introduce our own proud alumnus, Dr. Rajendran Venugopal, as today's resource person. So Dr. Rajendran Venugopal, he has been working as assistant professor at the School of Basic and Applied Sciences, Department of Chemistry, Central University of Tamil Nadu, Trivandrum. And I'm so happy to brief about his curriculum vitae. Sir has completed his BSc degree at our own college during 1996 to 1999 batch. Then he got MSc degree at Ayanada Janaki Ammal College, Sivagasi. Then Sir received his PhD at Bharatidasan University, Tiruchirappalli on the title DNA binding with some metal complex under the guidance of the great Professor M. Palaniandava sir, the yesterday resource person. Then Sir has enriched his research experience as postdoctoral fellow at Institute of Chemistry, Academia Sinica, Taipei, Taipan University under the supervision of Professor Jian Tusen Lin. Then Sir has some awards, prizes, and recognitions during his research period as well as to till date also. Notably, Sir has awarded with the Raman Fellowship for Postdoctoral Research Fellow in United States during 2015 to 16 by UGC India. He also awarded with the International Short Visit by Switzerland, that is University of Zurich, Switzerland for 2 months from June 16 to July 16. And also he received Taiwan National Science Council Postdoctoral Fellow during 2007 to 2010. He also received Young Scientist Award from a DST SERB Fast Track Project. Sora has also qualified GATE exam with a percentile of 81.75% and also CSR lectureship during 2003. With his research career, Sir has visited so many countries including China, Taiwan, Switzerland, Germany, United States, as well as Singapore. Notably, Sir has acted as a reviewer for the prestigious journal Inorganic Chemistry at American Chemical Society publication. He also acted as a life member for Indian Crystallographic Association and also board of study member at Holy Cross College, Tiruchirappalli. His area of research interests include metallosynthetic nucleus and protease development, metal-based anti-cancer drug development, synthesis of metal-based fluorescent bioimaging agents, designing of photodynamic therapy, nanomedicine, as well as radiopharmaceutical chemistry. So in this regard, Sir has published so many research papers at well-reputed journals like Polyhedron, of course, Inorganic Chemistry, Coordination Chemistry Review, and RSC Advances, Journal of Inorganic Biochemistry, with a total citation of 1,792, with an average impact factor of 3.99, including the H index of 15, along with the I index of 15. And also, Sir has sponsored with the various projects funded by SERB, CSIR, DPT, with a grant amount of so many lakhs during various periods. And Sir has attended so many lecture workshop conferences and symposia. He also authored 2 book chapters in development of chemosensor for the detection of heavy metal ion, as well as porphyrin and phthalocyanine radiolabeling. Sir also has a teaching interest and he has continued his teaching in integrated MSc and MSc more than 10 years. Currently, he is guiding more than 4 PhD students and one of the students got awarded. Okay, with this short intro, I would like to call upon Dr. Rajendran sir to deliver his lecture on targeting cancer cell with small molecules. Welcome you, sir.
Thank you, Dr. Raja, for your nice and kind introduction. Am I audible?
Yes, sir. Yes, sir.
Okay. Thank you once again. So really, it's a proud moment to me, and also I'm very happy to present my work so in front of this scientific community. So the first thing is, I'm an alumni of this college, Vivekananda College. So 1996 to 1999, I studied BSc Chemistry over there. I graduates from there 1999. So it has great experience. I started my graduate degree from Vivekananda College. I'm thankful to all my teachers. Okay, like start from Professor Tangamuthu, to Professor Sevel, Professor T. Rajendran, then Professor Ganeshan, so Subramanian sir, Mohan sir. So those all the faculty members, those served those time. So now I visited 2011. After that, I gave a talk on other conferences. I could see a lot of developments in our college. They promoted to research department. So I was so happy to see a lot of progress there in our college. So after the experienced teachers retired from their services, then the young faculty members, the team headed by Dr. Going to be Dr. Like Sevaramuthu and other faculty members, they're really doing a very good job in the college and running the department very dynamically and doing a lot of research and doing a lot of outreach program like this, and then doing a lot of academic activities, organizing conferences, faculty development program, enrichment programs, many activities. So I'm happy to see the progress. I wish the same progress which it should continue in future, and our department should come in a great level, should reach a great height. Okay, that's why I extend my thank to the management, Swamiji's, then principal Dr. Mudesan sir, then the department, Dr. Several Muthu, and faculty members invited me and given me opportunity to share some research findings of our research group in front of the esteemed faculty members and then young students. Okay, thank you, Wandal. Then I share my slide. If any difficulties is there, then you could stop me. Okay. Okay. Oh, sorry. Why it's not sharing? Some difficulties there. Must grant permission to screen share. Someone to give permission to share my screen. It says like that. Hello, Raja. Hello. Hello.
Sir,
Yeah, it asks now. It's
Yes,
like
sir.
you can't share your screen. You must grant permissions in order to like that. It says.
no, okay, sir. The 1 minute, sir. 1 minute.
Okay. Okay.
இல்லையா அப்படியே இது? Sir, as per the settings, anyone in the meet can share their screen, sir. I don't know on your side.
Okay. So wait a minute. Then.
We have not restricted to anyone.
Anyone? Okay. Okay. So, others, can I rejoin? Okay.
Yes, sir. Sure, sir.
Maybe I rejoin. Okay.
Left, right, meeting of left, right. Sir, please unmute your audio, sir. Sir, your audio is muted.
Okay, now it's fine.
Yes, sir, it's appearing. Yes, perfect. Proceed, sir.
It's fine. Are you able to see my full slide?
Yes, sir. Yes, sir. Yes, sir.
Okay, okay.
Yes, sir, it's visible. Targeting cancer.
Yeah. So my today talk on targeting cancer cells with small molecules. The title itself, we could able to understand what I'm going to talk today. Okay, you might have heard the seriousness of the cancer disease is one of the deadliest disease. Okay, might have come across many times. Maybe it happened to your neighbors or some known persons. Like person is died with the cancer or suffering from cancer. Okay, you heard from others. Okay, that's why this this is like designing a complex, designing a compound or drug molecules to eradicate cancer is still is highly wanted field in the field of pharmaceutical chemistry. Though many diseases emerging like COVID-19 or other viral based diseases or other deadly diseases are there. So designing a drug molecule for cancer receiving much attention is for many decades, So today my talk mainly on this targeting cancer cells with small molecules. Okay. So what we are doing before going to talk on the specific topic, the specific title of my topic, I would like to showcase to the audience like what we are doing in our lab in Tiruvarur, Central University of Tamil Nadu. So initially we were more concentrated on developing nucleic acid probes and artificial metallonucleases and proteases. So we start publishing some papers on that, making some metal-based compounds for imaging nucleic acid, and also developing binding agents for nucleic acids and proteins. Then we develop the artificial metallonucleases and proteases. The name itself, you would be able to understand. The ACE means the enzyme. The enzyme, artificial enzyme, which is cleaving the nucleic acids and proteins. We developed in our lab. We published some papers. Then we move to developing, based on this strategy, we move to developing some of the metal-based anti-cancer agents like copper-based, mainly copper-based. Then some of the ruthenium compounds also we developed. Okay, then we published some of the papers in Journal of Coordination Chemistry, then Polyhedron, the RS Advances. Some papers we published. Then off late we concentrate more on working on nanomedicines. Here we are encapsulating whatever cytotoxic compounds we developed in our group. Okay, then we encapsulate within the nanocarriers and try to deliver the cytotoxic or the anti-cancer agents at cancer site and leave the normal cells healthy. Okay, that's mainly my focus, my talk today. How to target only the cancer cells and leave the healthy cells, okay, undisturbed. Okay. Then another part is recently we are working on photodynamic therapy. Then here the drug molecules active when we set the light on the drug molecules. So in absence of shedding light or irradiating light, the drug molecules almost inactive. Okay, under dark is inactive. So when you pass a light, you are dynamic. You make the molecule dynamic. The drug, you make the drug in dynamic or an action. So it's called photodynamics. By irradiating light, you are making drug as dynamic. So it's a photodynamic. Dynamic means active. It's called photodynamic therapy or drug development. So many people are working in our country and also in abroad in this field. Now our strategy is slightly different from that. These are the overall view of our research interest. Even Dr. Ilaiyaraaja mentioned is my introduction, what are the areas we are working on it. So this small introduction, if I go is easy for the audience to follow my talk. Okay. So as I discussed with Sevaramuthu, overall audience will be in my talk. Then we said some students also there in my talk. Then I would like to start with some basic introduction. So rather than straight away going to my talk, then only it's easy to follow. Okay, my talk. So if you understand what we are going to do okay, in our laboratory, what am I talk mainly focusing, if you are able to understand through my introduction, then it's easy you to follow, okay, what I'm now going to talk today. So what's a cancer? All of you know that I don't give much introduction, but even though I start a little bit of introduction, okay, that would be better for the young person. Okay, the cancer is a genetic disease. So you know, genetic disease leads to abnormal cells divide in an uncontrolled way. So take a normal cell. So every cell in our body is like so it's like over the time it's divide into two or the multiplication. Through the multiplication is divide. Okay, that means it's called a cell growth. Okay, it dividing in controlled fashion. It dividing through like mitosis, meiosis process. Okay, divide means the growth. Okay, it's growth. Okay, or the growth into different parent cell gives a daughter cell, then daughter cell become a parent cell, like it is another daughter cell, like this way is growing, cell is growing. Okay, so like every minute millions of cells is going to die, dying, then new cells are formed, it does the function, then after does the function it goes to die. Okay, so like if during the cell division, if any cell is injured, just see this the right hand side diagram. I can also take the pointer. Okay, if any a cell is get damaged, okay, if any cell is sorry, should take the pointer. Okay, yeah, if any cell gets damage through repair enzyme, okay, through repair mechanisms, okay, so it cells get repaired. That's called the repair enzymes are there, okay, in our body. So recently, the 2-3 years back, this invention got a Nobel Prize. There is many repair enzymes are there in our body. So after gene synthesize, I mean the DNA sequence synthesize, then you scan the DNA sequence wherever the mismatching or the mutation there. So the repair enzyme repair it. The kind of workshop, kind of a workshop duties done by the repair enzyme, to repair the mismatched genes. So if even some of the mismatched genes escape from this repair enzyme, so that gene or that cell is going to involve in a cancer. Okay, the mutated cell is going to a cancer. Okay, if not properly removed or killed. Okay, so like this way, like even the childs or those who are not exposed to different environmental factors, or now even people are saying that, sir, I'm not addicted to any like bad habits like alcohol, smoke, or any environmental factors, but okay, like I got cancer, or some of our friends he's a clean person. Okay, that means he hasn't involved in any kind of bad activities, but he has a cancer, like that. Even the child, what the child did. Okay, so thing is due to gene mismatching. Okay, thus repair enzyme almost it does the job, but sometimes even that mutated one escape from this repair enzyme, that leads to the cancer. Okay, so in that case, there is like in our body one program, one process there, like apoptosis process. If any like gene escape from repair enzyme, the apoptosis process is operated on this. Okay, then it kills the cell in proper way. Okay, and removed from our body body through some excretion method. Okay, that process called apoptosis process or programmed cell death. So this cell death is already programmed. Okay, or it's a biological way of cell killing and properly remove body. But what these cancer cells are different from the normal cell. So even is mutated or get injured, the apoptosis process not happen. Okay, not activated in the case of cancer cell. That leads to multiplication of cells, or multiple growth of the cells, or leads to uncontrolled growth of cells. Okay, so what's the main duty of the drug molecule? To activate apoptosis process in cancer cells, and should kill the cancer cells through biological way. That's very important point you should keep in mind. But also this cancer cell lost its like growth control. Many the hallmarks or the biological pathway is different from normal cells. Like it lost the growth control. The growth control factor is controls the cell division. How many cells should divide? How long should division should be there, like that. But this cancer cells, one of the main hallmarks is it lost its growth control. That's why keep on growing. There is no apoptosis. Okay, then the mutated cells keep on growing. That's why uncontrolled, cancer, cells growth happen. Then it leads to like benign tumor. First, initially it's a benign tumor. Okay, then it's a benign tumor is inward neighbor cells and spread through. Okay, the blood, blood. Okay, no, it's like mixed with the blood. It transport from one place to another place, through invasion. Then it leads to metastatic cancer, secondary cancer. If you identify a person at benign cancer, we could be able to save the person. If person is undergone, if happen to be a metastasis process, a secondary cancer, cancer is advanced cancer, it's very difficult to cure the person. Okay, these are the elementary aspect of cancer. With this knowledge, we move forward to further discussion. So, what are the hallmarks of cancer? As I told you, so it's a sustaining proliferative signaling. That means you keep on, the cells has to grow like this. Then avoiding growth suppressors. So there is a growth suppressor proteins are there, or factors are there, suppress the growth or control the growth. That lost. Okay. Then activating invasion and metastasis. That means invasion and metastasis means it penetrates through, okay, or the vessels, then it mix with the blood, then is it transport or migrate from one part of the organ to another part. That's highly dangerous one. So the spread of cancer from one part to another part called metastasis. Okay, then enabling replicative immortality, inducing angiogenesis. So nothing but angiogenesis means the blood vessels are forming, arteries are forming on the cancer cells. So each cells it needs oxygen, nutrient to grow. So the process called the development of the blood vessels on cancer cells is called angiogenesis. Okay, so through which it uptakes a lot of oxygen molecules, nutrients to grow. Okay, grow faster. Okay, then resisting cell death. It's not like inducing or welcoming the cell death factors. So these are the things, main hallmarks of cancer. It differs from normal cell. That's why it keep on growing. Okay. So there is another like strategy or strategy in targeting these cancer cells. Okay. So here if you see this, the therapeutic targeting of the hallmarks of cancer. So like what are the hallmarks? Whatever we saw in the previous slide. So based on that, we have to develop some of the inhibitors or some of the drug molecules to block or inhibit the proteins or enzymes which are enhancing the proteins. Yeah, enhancing the proteins. And also we should stabilize. We should stabilize or protect those enzymes which is suppressing the cancer cell growth. That's the main aim here. That's a target specific. That's a molecular target specific. So here we are now. The main thing is through receptors. Okay, the receptors which is secreted or expressed on the on the surface of the cancer cells. Okay, to receive some of the nutrients to grow itself. Okay, grow faster. Okay, so if you block those receptors, so the nutrients will not get into the cancer cells, or the nutrients uptake will arrest or will stop by this blocking of the receptors on the cancer cells. So that's one of the strategies. Okay. Another strategy is can also target the nucleic acids which are responsible for growing the cancer cell. So another strategy is targeting the proteins which are responsible for growing the cancer cells. If you go through this, there are different cyclin dependent kinase inhibitors, like epidermal growth factor inhibitors, like immune activating the telomerase enzyme inhibitors. Okay, selective anti-inflammatory drugs. Okay, that drugs is going to inhibit the anti-inflammation. This is called anti-inflammatory drug. Then inhibitors of some of the human growth factors. Okay, then different human growth factors. It inhibits. Then PORF signaling inhibitors like pro-apoptotic. Okay, BH3 mimetic. Okay, are inhibitors. Then glycolysis inhibitors. So many inhibitors we can develop through which we can inhibit those proteins which are those enzymes which are helpful for growing the cancer cells. Okay, this one kind of molecular approach you can do that, but it's not easy. So talking is easy, but executing is not that much easy. Okay, so my talk today is mainly what are the strategies we can use to target the cancer. Okay, that's important aspect of my talk today. Okay, as we know, there are people are saying more than 200 types of cancer there. So out of that 100 types of cancer is almost is aware that based on the name and the organ specific and also the origin specific is there. some of the cancer I highlighted. These are the cancer is most prevalent cancer or no most familiar cancer which is now present like the people are affected. Most of the people are affected by this cancers. Okay. Things. Yeah, the cancer statistics in India. Why we need to do research in cancer, even though the COVID-19 is there, the new viral based diseases are emerging like HIV based, like COVID, SARS-CoV-2, then SARS-CoV-1. So like different though many viral based diseases are there, and bacterial based diseases are there. So why should target do research towards these kind of genetic based diseases? Okay. You see on the statistics, right, took from the cancer statistics, cancer India .org.in. So you can see here, so one woman dies of cervical cancer every 8 minutes in India. So I'm not saying this is statistics saying. You can also refer this, okay, the site which I given below. So for every 2 women newly diagnosed with breast cancer, 1 woman dies of it in India. So if a 2 women is diagnosed as breast cancer, 1 woman is almost dying. 50% death rate is there in case of breast cancer. So mortality due to tobacco use in India estimated 3,500 persons every day. Okay, they are now using tobacco. Because of that, they are encountered a cancer. Okay, so and also like if you see tobacco use, whether the smoked one or non-smoked one or smokeless one, use accounted for 3,17,928 deaths approximately in men and women in 2018. So it's huge amount. Then total deaths due to cancer in 2018, if you see, 7,84,000 1,821, and among them men is for around 4 lakh, like women around 3 lakhs. You can see here. So this the death rate is compared to COVID up to March 31st, 2021. There's a 1,62,501 in India. Okay, compared to the COVID virus, coronavirus. So the cancer is highly dangerous. Okay, I'm not saying this corona is not dangerous, even that also, but somewhat we found some mechanism to overcome that, but still cancer we are not able to do that because it also is based on the gene. It involves many or different kinds of cancer. Okay, if you find a drug for one type of cancer, the other cancer is emerging out. Okay, so like these are the difficulties we have. Okay, so what are the different cancer treatments nowadays people are adopting to cure the cancer? So first, foremost is surgery, then radiation therapy, then if we come to the different gene therapy, then immunotherapy, so bone marrow transplantation. Okay, then photodynamic therapy, they are using from 1992. Then targeted therapy approach from 1985 is there. So, but as a chemist, we are mainly using or talk about chemotherapy. So chemotherapy nothing but using chemical drug molecules to treat the cancer. Okay. So categories of chemotherapy drugs. Okay, is based on that they are classifying these chemotherapy drugs based on its action. The first category is stop the synthesis of pre-DNA molecule building blocks. So here, so like if you take a cell, so nucleus is there. Okay, the nucleus, the nucleic acids are there. The nucleic acids are the controlling genetic material. It controls everything. Okay, so like if you stop the material pre-DNA materials needed to synthesis DNA. If you stop that, if you block those molecules to supply to the nucleic acids, then you would be able to stop the progressing of like cancer cells. That's the way these drug molecules are acting or blocking DNA like building blocks molecules like take different cancers they're using these are the drug molecules. Okay, like the things like take methotrexate, then fluorouracil, hydroxyurea, then mercaptopurine. So many drug molecules it's FDA approved. People are being used to cure some other cancers. Then directly damage the DNA. So in the cancer cells, the nucleus of cancer cells. So one of the very famous the metal-based compounds is platin. The commercial name is platinol. Then donorubicin, doxorubicin, etoposide. Okay, there's many drug molecules there. I given below what are the cancers. You can treat by using these molecules. Okay, these drug molecules. Then third category is affect the synthesis or breakdown of the mitotic spindles. The mitotic spindle is one of the important steps in dividing the cells. So if you don't block this mitotic spindle formation, then we can arrest the cell growth. Okay. These are the way, okay, so they are classifying the already known drugs. So in addition to the organic based drugs, in addition to cisplatin, there are other metal based anti-cancer drugs approved by the FDA. So like gallium nitride for hypercalcemia malignancy, then like arsenic oxide, then carboplatin, oxaliplatin. Okay, these are drugs already there. Okay, the commercially available drugs, but though it is available and people are using for treating cancers, it has its own merit, own merits as well as demerits. So it person to person, it gives a lot of side effect. Okay, one person is okay, go very well. Okay, then if you treat other person, it gives a lot of side effect. So normal side effect, no. In the case of chemotherapy, when you treat, so nausea, then vomiting, okay, then no hair loss, okay, then like some kind of no side effect gives. Even kidney failure is another major side effect people are encountering when they're giving chemotherapy. Okay, these are the major side effects. Is that, but it depends on your immune system. Okay, it like your the body condition of the patient. Some other patient can able to overcome this side effect, then they're curable or get rid of from the cancer. But some patients, even though after treatment of chemotherapy, they're struggling. Okay, so advantages of using metal complexes as anti-cancer drugs. So most of the complexes are charged and water soluble, but if you have organic compounds are not water soluble, so solubility issue will be there. Then absorption problem when you treat in vivo, just we are encountering. So this metal complex is somewhat better compared to like organic compounds. It has some specific action also. Yes, some metal complexes. So most of the cationic form is soluble in biological fluid like water. Then there's a possibility of ligand exchange. If you want to exchange or if you want to change a ligand or want to bind with, for example, in case of cisplatin, go and bind with guanine N7, okay, of DNA, there is exchange happen between aqua ligand and this, N7 guanine. That also possible in case of, okay, the metal complexes. Then redox activity. Through redox activity, could be able to produce reactive oxygen species, okay, in the biological environment, through which we would able to, okay, make it unbalanced, or be able to elevate reductive oxygen or reactive oxygen species like hydroxyl radicals and singlet oxygen in on the cancer environment or around cancer environment. Okay, through which we would able to kill the cancer cells. So in our body, it's already many reactive oxygen species are produced in order to okay, destroy some of the unwanted materials in the body. If it is exceeds over the limit, the same reactive oxygen species kill the cancer cell. But the cancer cell and normal cells, both the cells, there is no production of some reactive oxygen species that's called ROS. Okay, reactive oxygen species like hydroxyl radicals, superoxide, then singlet oxygen. Okay, these are the reactive oxygen species you might have heard. Okay, that's already produced in the body not to control, in order to degrade some of the unwanted materials. But at the same time, it exceeds over the limit, then it disturbs. Okay, there is no control. Okay, the reactive oxygen species control. It disturbs the redox. Okay, activity of the cells. Then leads to overproduction of reactive oxygen species. Then the cell is going to die. For example, in case of copper complex redox active one, we use in the biological environment in presence of reducing agents like ascorbic acid and glutathione inside the cell. It undergoes reduction from copper 2 oxidation to copper 1. Then hydrogen peroxide present in the cells, it can oxidize back to copper 1 to 2. Due to this reversible redox reactions, there is a chance of producing hydroxyl radicals through Fenton mechanisms. Okay, then this hydroxyl radicals is damages the cancer cell. This is a mechanism. Okay, like I structural diversity. You want to make square planar compound, you can make. If you want to make tetrahedral, you can make trigonal pyramidal octahedral. You can do you can vary the structure by changing ligands. These are the advantage of using metal complexes as anti-cancer. But at the same time, so it has also demerits. Okay, if you use biocompatible metals like platinum and ruthenium and some other metals, their side effect will be more. If you use biocompatible metals like copper, zinc, and iron, so then other cobalt and other complexes, the side effect will be less. That's why we are mainly focusing on the copper-based compounds mostly in our studies. Okay, rarely we go for ruthenium-based compounds. Like the thing is, we can develop a compound, we can develop a complex, we can test cytotoxicity or know the anti-cancer activity. But the question is whether the drug molecule is only targeting cancer cells, okay, and you have to make sure you should not touch the normal cell, or you should not kill the normal cell. This very, very, very difficult thing is, so if you see the morphology or the activity of the cells, okay, metabolic activity of the cells almost similar. Normal cell and cancer cells similar. The drug molecules can't be able to distinguish, okay, which one is a normal cell and which one is the cancer. That's highly a challenging one. So so the need of developing the target-based, okay, or target-oriented, or the targeted drug delivery, or target-based, okay, drugs, have to be synthesized. Okay, so that's why my major focus of the drug. So if you're like making a target-based drug, okay, it's not easy to target the cancer cell, but it has a lot of challenges. It's not easy. So for that, we should understand what are the differences between normal and cancer cells. So from that, we could be able to develop, okay, our drug molecules. So we see the left-hand side, the normal cell properties are there. Right-hand side, the cancer cell properties are there. Okay, the normal cells are regularly shaped and non-leaky one. The cancer cells are that vessels are the blood vessels is like irregularly shaped and a leaky one, because very fastly is making, like through angiogenesis process, the blood vessels are making very fast. So because it is an urge, it needs more nutrients. That's why so growing very fast. It is in more, okay, it needs more nutrients. So it's the vessels are forming, okay, like irregular way. Okay, then the leaky environment will be there. Then glutathione level is normal in case of normal cells, so it's 7 times higher in the case of the cancer cell. Then pHs is like physiological pH is around normal cells, then acidic pH environment around cancer cells. Like folate receptor, so the receptor which is receiving folic acid. The folic acid is one of the main nutrients to grow the cells. So this is overexpressed on the cancer. This is a very, very important point you should keep in mind. Then only you can be able to follow my forthcoming slides. Okay. The folic acid receptor is called folate receptor, which particularly receiving or uptaking the folic acid through endocytosis process, like like kind of a cell engulfing. Okay, so when it's attached on the surface, it forms like kind of a sac. So through the sac, it gets into this cell. That process called endocytosis. Exocytosis means is expelling out. Okay, is sending out. Okay, endo means going inside. So then through like lysosome sacs are formed. Lysosomes are damages the sac. Then the folic acid release inside. It helps like grow the cells. So if you block that folate receptor by using some of the like blocking agents, you could stop cancer cell growing. Then another thing is a transferrin receptor. Kind of transferrin protein, you might have heard that this kind of iron transport protein, that's also useful or needed for growth of the cell. So through transferrin receptors, the transferrin gets into the cancer cells. Okay, so this then another thing is like L-amino acid transporter, glucose transporter. Many transporters like many receptors are there in both normal and cancer cells. So what the difference? The receptors are there in both normal and cancer cells. Because normal cells also should grow, it is there. But the main difference is these receptors are more expressed or overexpressed on cancer cells compared to normal cells. So using this strategy, we are like if you're like passing our drug molecule or administrating our drug molecule through different strategy, if you inject the drug molecule, so compared to normal cells, okay, there is a more chance of uptaking or attacking the cancer cells compared to normal. So this is a strategy. But there's drug molecule may also bind with normal cells. The normal cell has some kind of self, okay, like sustain mechanism, or it recognizes that some foreign molecules comes, it escapes from that. Okay, it won't uptake that. Okay, but the cancer cell, it is in urge. Okay, it's growing very fast. So whatever molecules are coming, it approaching the receptor, quickly uptake that. Okay, so based on the strategy, we are now developing this target oriented, okay, like drug molecules. You see this slide, you can see how many receptors are expressed, okay, on the cell surface. Okay, take biotin receptor, RGD peptide, okay, receptor, it's kind of cell homing peptides. Okay, then folic acid, folate receptor, like epidermal growth factors. Then estrogen receptors are there. Then some of the proteins like peptide is going to bind to some of the proteins. Then like different like transferrin receptors. So for example, in case of breast cancer, I take these are the like receptors are expressed on the cancer cell. In addition to that, so L-amino acid transporter. So they are particularly transporting L-amino acids for synthesis of proteins. Like many receptors are there. Okay. So here these cell receptors are there. So compared to normal cells, can see the cancer cells, expressing more receptors because it's growing very fast compared to normal cell. It needs more nutrients to grow. That's a very important point to keep in mind here. Okay. So, like, what are the advantage of targeted drugs can work to block or turn off chemical signals that tell the cancer to grow and divide, and change proteins within the cancer cell so that cell is going to die, cancer is going to die. Stop making new blood vessels to feed the cancer cells. Okay, through the blood vessels only. So the feeding is going on. That will stop. Then trigger your immune system to kill the cancer cells. Then carry toxins to the cancer cell to kill them, but not normal cells. These are the working mechanisms. Just see one or two slides. I see what the strategy behind in designing the target based this drug molecules. You see, okay, in the case of normal cells, also now receptors are there, but they express in controlled way. In case of cancer cells, you can see the overexpress, okay, compared to normal cells. And then if you administer the drug molecule, there is a more chance of targeting these receptors on the cancer cell than the normal cells. So what are the receptors and targeting ligands? If you see that, so these are the main receptors mostly people are using to target. So like examples, folate receptor, L-amino acid transporter, transferrin receptors, integrin receptors, and glucose transporters, mitochondria within the cells, then DNA and proteins. Okay. So like on the cell surface, up to up to 5 receptor based on the cell surface, mitochondria within the cell, then DNA is within the nucleus, and also protein in cytoplasms. Many proteins are involved. So mainly the 3 category strategy we are using. One is receptor targeting. Okay, and my talk mainly on targeting receptor targeting strategy. Another strategy is nucleic acid targeting strategy. Third one is protein targeting strategy. Okay, these are the molecules like RGD peptides, folic acid. Okay, the L-amino acids normally, in the case of L form, then glucose, targeting glucose transporters, like DPPs and mitochondria targeting agents, tryptophan, phosphonium cation is mitochondria targeting agents. Already people have been explored these targeting agents to target cancer cells. Okay, so this strategy, as I told you, so one animation to understand that. So once this target attached, nanocarriers or the drug molecules approach these targets through endocytosis. So you can see here this figure, the right hand side on the top. So is there through endos once the target it approaches this receptor, it forms kind of sac. It's kind of a nuclear cell membrane sac, okay, or packet. Then it's engulfed this drug molecule, then get into the cells. So this packet or sac has lysosome inside. Lysosome is kind of a digestive enzyme. It digests this sac, then releases drug molecule inside. Okay, so if unwanted material is there through exocytosis, same way it's eject the unwanted materials that also there. So through endocytosis, drug molecule entered, then it attack mitochondria, nucleus. What are the targets? It attacks. Then it kills the cancer. This is a strategy. So using this strategy, okay. So we are developing some molecules. So in our lab, we have synthesized some of the copper-based compounds, simple copper-based compounds. We tested the cytotoxicity of those compounds. Then we picked the good cytotoxic compounds. Then we go for targeted approach. But when you have small molecules, then people are publishing out of papers. They're presenting some work. So they're developing a compound or drug molecule or copper compounds or any complexes. They're testing. Okay, they're interact with DNA, protein. I think you might have heard from Professor Pangandavar talk. He talk on how this drug molecules bind with DNA and proteins. Okay, how these metal complexes binding with the DNA proteins. So from which how this molecule, then he correlated, correlated. Okay, how this molecule can affect cytotoxicity on cancer cells. Okay, but thing is, these molecules are like kind of blind molecules. Not blind means so it don't bind so all the cells, even normal cells can. There is a chance. There's selectivity maybe less. Okay, compared to the target one. Okay, these molecules wherever it binds drug like cells or the biological targets, it don't binds and kills that. So due to this, okay, so the side effect will be more. So we can't use these molecules directly for treatment. So in this case, so we planned on strategy. So in our group, we synthesized these 7 complexes. It's one side have amino acid, L-proline, other side this diamine. It's very simple complex. they're designed. If you go like the case of biomedical research, if you go like bigger molecules, very difficult to target, or very difficult to solubilize. Many things are there. Okay. Then we characterize using X-ray crystallography and EPR structural studies. I'm not going to discuss those things because my aim to show you how we are developing the target-oriented compounds. Okay. Then we tested cytotoxicity using a non-small lung cancer, carcinoma by A549 cancer cell line. You can see here we tested that. So based on the IC50 value, that means the concentration needed to kill 50% of the cells. Okay, in the particular the cell well. Okay, particular concentration of the cells. Okay. So see there we see here. So like the compound which dimethyl phenanthrone, this compound, one side is proline, other side is 5-cis GMP molecule, and then the compound 6 you can see the L-proline and DP2 complex. Okay, this 2 complex is affecting good cytotoxicity. You can see here. So in the case of 1.28 micromolar in the case of DP2. Okay, so another compound you can see the tetramethyl that gives this less high IC50 value or less cytotoxic one. Okay, with this we took this this DP2 compound and one less cytotoxic compounds we take into our further encapsulation studies. Through cytotoxicity and apoptoticity, all those things we tested through different training methods. I hope Professor Palnandavar talked all those things techniques. Okay. Then we confirmed this cytotoxicity through ROS generation study. So these molecules are producing more reactive oxygen species in cellular medium through which it affects cytotoxicity. Okay. So we confirm the cytotoxicity through some studies. Then we take these molecules for further studies. And also we have now taken another series of copper complexes. We synthesis some dipeptide the tridentate ligands, and on the other side now we taken the same type of diamine ligands. We synthesize and characterize using different techniques, spectral techniques. Then we tested this cytotoxicity on MCF breast cancer cell line. You can see here. So through this Western blot studies, you can be able to see the compound induces cytochrome C protein and caspase-3 protein. These are the proteins are cancer suppressor proteins, which are these complexes, particularly this tetramethyl substituted complex. You can see here one side is dipeptide, other side this tetramethyl substituted compound. This compound effect very good it induces the expression of cytochrome C and caspase-3. So in the case of apoptotic mechanism, the complex induces cytochrome C and caspase-3 through intrinsic mechanistic pathway. It kills the cancer cell. This is another area, so I'm not going to talk on this. First know what the way it kills the cancer cell. So using this but this complexes, as I told you, is non-specific. It may also kill the normal cells. We didn't test with the normal cells because now we are going to encapsulate this molecule into the nanocarrier. So what we are doing, we are going to targeting based on the receptors. We are developing targeting molecules through the receptors. So here the copper-2 complex encapsulated folate functionalized MSN nanocarriers for selective targeting of the cancer cells. So what we have done here, the mesoporous nanosilica, very famous, well-known method. So most of the people using in this nanomedicine method, it's a little old method, but still people are using is more convenient method to target the cancer cell. So they are making different way to make the mesoporous nanosilica. You can see here it has the pores over here. Through on the pores, we can able to encapsulate whatever the cytotoxic agents inside the pores. On the surface you can also decorate or you can conjugate with cancer receptor targeting ligands folic acid on the surface. So one strategy we are using attaching folic acid on the surface. We are trying to target the cancer cell. Other strategy we are adding rhodamine dye, fluorescent dye, because copper complex is non-fluorescent one. So whether it reaches the cancer cells or whether it gets into the copper complex, then we co-loaded rhodamine dye. So rhodamine dye is get into the cells. When you irradiate the light or when you keep under imaging fluorescent imaging microscope, you would be able to know where is whether this enter into the cell or not. Then finally capped with silver nanoparticles. So now the copper complex encapsulated with rhodamine and finally capped with silver nanoparticles. It acting as a gatekeeper. It doesn't allow the drug molecule to come out in the normal environment. But these silver nanoparticles plus no glutathione. Okay, so the glutathione is present more inside the cancer cell than the normal cell. So once this the like nanocarriers enter into the cancer cell through either passive diffusion or active diffusion, like different targeting strategies are there. Okay, once you get into the cancer cell, then GHS glutathione react on this cellular nanoparticle, then there is a release of our cytotoxic agent inside the cancer. So it's one strategy. Another one, so this the folic acid it targets the folate receptor which are expressed on the cancer cell. Then through endocytosis method is get into the cancer cell. There there's there's a release happen inside the cancer cell. Then it kills these copper complexes can capable of producing more ROS inside the cancer cell. Then it elevates the ROS production through which it kills the cancer cell. This is a strategy we have followed. We encapsulated two like cytotoxic agents which are synthesized in our lab. This is synthetic strategy. Now we can refer many reviews or papers already. They're publishing this. Okay, it's not a new one. So it's many people have tried, but our strategy is different. Our complex is different. Okay, so through which nanoparticle can capped on the MSN surface, and also attaching through covalent mode, we can attaching folic acid on the MSN surface. Okay, so through same images, you would able to characterize nanoparticles whether loaded or not. All those things you could see, and also the EDOX experiment. Okay, you could be able to see the presence of copper and silver. So these two metals are there. That means our copper compound has been encapsulated properly, and also silica is also there. Okay. So after confirm, the drug loaded, mechanism or loaded thing, then we are testing, the cell homing test, whether it get into the cells or not. So if we see here, this MK4 means this DPQ complex encapsulated one. So this one is tetramethyl encapsulated one. So we first tested with the normal cell. You see here, this compound also entered into the normal cell. Okay, also enter into the normal cell. But I'm not saying it's only targeting the cancer cell. If you see the next diagram, this is a normal, this is a cancer cell. The same cell line. Important thing I taken same origin. Okay, A549 lung cancer cell. The important thing when you compare the normal cell and cancer cell, you should also take the same origin of the cells. Some people are now using breast cancer cell for the cancer cell. Then they taking kidney normal cell to compare that. That's also okay, but it's not if you see that it's not a correct strategy to do that. Okay, so you should also take same origin. If you see the cancer cells compared to normal cell, you would be able to differentiate the cancer cells uptake more compared to normal cells. That's the important thing. Okay, so this is a rhodamin emission. That means the drug is it enter into the cancer cells compared to normal cell. Okay, then we tested for cytotoxicity, whether this encapsulated nanocarriers is release the drug molecule, is a cytotoxic agent, whether the cytotoxic agent kills the cancer cell or not. We tested. First we tested with normal cell. You can see here the cell viability is for the normal cells only slightly disturbed, only 10% cell kill death only there when we treat with this the cytotoxic agents in the case of normal cell. When come to cancer cell, you could be able to see the case of MK4, MK5. You can see this MK4 and MK5. This MK4 is this compound DPQ, encapsulated one, and MK5 is tetramethyl encapsulated one. So both compounds is silver capped. Okay, a silver capped one. Okay, it shows some level of cytotoxicity. You can see here. Okay, the 1 microgram and 10 microgram. In the case of 10 microgram, is 55% cell death happen. But when you take folic acid attached, MK2, nothing but this folic acid attached compound. Okay, folic acid attached copper encapsulated nanocarrier. You can see here the percentage of cell kill is more. So 10 microgram is less than 50, around 50%. Okay, the cell death happen here. So this based on this, we confirm that this folic acid encapsulated one, it demonstrated more cell death. Okay, and also is almost compared to normal cell, the selectivity or targetivity is more in this case. We establish this concept by using the nanocarriers. Okay, then we next strategy. Why don't you directly conjugate this folic acid on copper complex? We thought that. So many compounds have been synthesized in the literature and reported, but this one is somewhat a different thing. So we are having like ROS production center at one place, then DNA binding agents, dimethyl phenanthroline tetramethyl DPQ to another side, like then other side, then cancer cells targeting ligand folic acid conjugated one. But this this complex synthesis, then we're trying to target triple negative cancer cell line. The triple negative cancer cell line is slightly challenging on to target because it does not express some of the receptors and proteins. For example, it does not express the estrogen receptor, progesterone receptor, and also human epidermal growth factors is absent in case of this triple negative. So compared to normal breast cancer, so targeting the triple negative cancer cell is highly challenging. Those people are encounter this triple negative is very difficult to cure the person. Okay, that's why developing drug molecule for triple negative is highly challenging. Okay, so here we can conjugate this the folic acid molecules. And using simple synthetic strategy, we prepared the metal complexes. You can see here. So we synthesize 4 metal complexes. Among that, this 5,6 DMP conjugated, then folic acid conjugated, copper complex affected 0.54 micromolar IC50 values. This is more toxic. Okay, more toxic to the cancer cells, but compared to the cisplatin, which has any folic acid. Okay, compared to that, isn't there. But here we couldn't test with the normal cells. Thing is, we are now this work is in progress. It's under thing is we submitted this result. So we are now finding some group to do in vivo studies. Instead of going normal cells, we plan to take it to in vivo. So the rat model, mice model, we are going to test whether it's going to work out or not. But here the conjugation of folic acid. So compared to if you have free ligand folic acid, the metal complex bearing or attached folic acid gives more cytotoxicity. Okay, that's important finding. Okay, here. Then so we are pass on to another receptor like L-amino acid. Okay, L-amino acid targeting molecules, receptor targeting molecules. Okay, see the here the photodynamic strategy we are following here. So as I told you in the reference introduction section, what's the photodynamic therapy? When you pass a drug molecule into our body, so before passing the light on our body, the drug molecule almost inactive. Suppose we have a cancer on the particular place, so you may be you have a cancer on the right hand or nose or finger. So first we have to pass the drug molecule into our body. Then you particularly shed light on the cancer affected region. Only the drug molecule activate that particular region, it kills the cancer. That's called photodynamic therapeutic method. So this is a localized one. This is a localized treatment, one of the non-invasive treatment method. Okay, this highly appreciable method, but it also has its own disadvantage. When the drug molecule or photosynthesized, irradiated by the light, it go to the excited state. There it produces singlet oxygen at the excited state. That the excited singlet oxygen will kill the cancer cells. Okay, that's the mechanism of the thing. By using this strategy, okay, we are having the photosynthesizer at the center. On the surface, we're attaching the target molecules, then to target specific cancer cells. So now the drug is FDA approved one. It's a for femur. It's a hematoporphyrin drug. The photophyrin, another name is called photophyrin. People are using this the drug effectively to cure the diseases. But this drug, this method can't be used for all the cancer diseases. It has its own limitations. Okay, but successfully you can treat bladder, early stage of lung cancer, esophageal cancer, and non-small cell lung cancer. All those things you'll be able to do that. So some are work already published based on this one. They're now conjugating amino acid on the some of the molecules. Then they are chelating with some of the radioactive nuclide. Then they are diagnosed or through L-amino acid transporter, they could be able to diagnose the cancer cell. Okay, so some of the cancer cells is overexpresses the LAD. One of the cancer cells is glioblastoma. Glioblastoma is a brain cell. This also overexpressing this LAD, L-amino acid transporter. Okay, so this is the amino acid can effectively transport through L-amino acid transporter leucine, isoleucine, valine, all those things. Okay, so based on this, okay, so why don't you attaching this lysine, L-lysine on the a porphyrin compound. The porphyrin compound already proven as the best PDT agent. So on the surface, So we're conjugating, L amino acids, the L amino acid as well as D amino acid. Not to compare the activity of L amino acid, we conjugate D amino acid too. Okay. So like we conjugate this, then we test photoactivity, photodynamic therapy activity. So purpose of attaching L amino acid to target L amino acid transporter. Then to compare, okay, L amino acid specific transporter, we are also attaching like D amino acid. Okay. So we see here this L amino acid targeting L amino acid transporter, then through endocytosis process get into the cancer cell. Okay. So this way, first we are make protecting one FMOC protected L amino acid first conjugate with this like porphyrin, then we deprotect it, then make it L and D amino acids. Okay. Then we take it into test for this the internalization or cell uptake, but one disadvantage we encountered for this molecule is there's this aggregation problem. So the solubility problem we encountered this, then we use very trace amount of the folate surfactant with this, then with the aid of this, then we could able to solubilize the compound. Then we did. Then if you see this L amino acid, it's tested, it internalized into the cells. D amino acid also conjugated also enter compared to D amino acid, L amino acid compounds entered more. But if you see that for PDT activity, photodynamic therapy activity, we see there, there is if you see here, if you irradiate light, at first we irradiate red light, it's always the compound having red light, irradiated one, or is producing toxicity red light, that's going to be more efficient one, or like more safer PDT agent. So we tested with 665 nanometer for 10 minutes irradiation, but we could see, so there are lysine based compounds also gives some cytotoxicity, but it needs more amount, like it takes at least 20 micromolar, then only affects 40% cell kill. Okay, but if you see like 440 like blue laser, then the cytotoxicity will be more. But if you see this, whether selectively binds L amino acid transporter, is a big question mark. I think it's due to the solubility problem. We could not be able to here find out whether effectively transported by L amino acid transporter. But some cytotoxicity is there, some internalization is there. Through which you could say some amount is transported through L amino acid transporter, but at the same time we could not say it, because even FMOC protected compound also get into this cells through some other mechanism. So still we are working on it, whether the specific binding is there or not. Then other thing is we inject this molecule in mice to see whether these compounds are cleared through renal clearance. Whatever drug molecule, whatever the compound you are doing, you should test in vivo conditions. It should come out after the drug action. If it stays inside the body, then it's due to a lot of complications. Am I right? So it should come out. So that's we have to test the renal clearance. That means whether it should come through like urine or feces. We have test. So we inject this photodynamic therapy molecule. So in the into the like mouse. Then we collect the feces and urine for 48 hours. Then after the 48 hours, we sacrifice the mice. Then we collected like heart, liver, spleen, lungs, and kidney, all those things. We tested how much compound still stored or how much compound is come out. Like that. So after the urine, we got some compound. The compound is coming out. You can see like yellow color. So compared to like D-lysine, L-lysine is coming out this place. And also it stays some compound in kidney and also liver. But it's not stored in heart, spleen, lungs, and all those things. It's so somewhat good sign, but still some compounds there in the kidney. But it should come out completely, otherwise it gives some other problem. So then we are working on it to develop the molecule to be a good L amino acid transporter as well as good renal clearance compounds. So another strategy you are following, I think this another strategy we are following, like nucleic acid targeting strategy. This one, so nucleic acid means which one is come to our mind is the DNA is come to our mind. Then RNA is come to our mind. So they come to the DNA. We actually about nucleic acid is mostly heard about. Like Watson Crick based models. Here we are developing towards the development of G quadruplex and I motif targeting DNAs. Those DNAs are non-canonical DNAs. If you take canonical DNAs like normal, double helix DNA is called bDNA. Normally bDNA called as the canonical DNA. But if you take non-canonical form, there are different DNAs are possible or formed in our biological system, like based on Hookstin and hydrogen bonding. So in the case of Watson-Crick hydrogen bonding, so our the normal the genomic DNA exists in Watson-Crick model, like whatever DNA we come across and so forth. So like the Hookstin hydrogen bonding is there, slightly different from the Watson-Crick model. The Watson-Crick model guanine cytosine undergoes 3 hydrogen bonding, but this one undergoes 2 hydrogen bonding. Okay, so based on this, so there are some non-canonical forms of DNA are present or exist in our biological system that start from G quadruplex. If the DNA has no G guanine-rich region, can form this type of quadruplex in our biological system. And also I-motive DNA is also forming when cytosine is hemiprotein. One of the cytosine is hemiproteinated. There's a chance of forming cytosine pair. Okay, then some of the parallel triplex form, then hairpin structure, then cruciform. These are non-canonical form. They're different from canonical forms. These are exist in the biological system. They have some connection towards the cancer one. For example, in case of stabilization of G quadruplex. That's why if you develop a compound which is stabilizing G quadruplex or the stabilizing I-motive DNA or inhibiting I-motive DNA, through which we could able to control the cancer growth. So one of the enzymes called telomerase enzyme, which helps the genome or gene or chromosome to stay a long time or grow for longer time. Okay, so if the telomerase is stabilized in the cancer cell, it helps the cancer cell to grow fast, helps the cancer cell to grow fast. But if the G quadruplex is formed or stabilized in the same chromosome, it depromotes the telomerase. Or you can see here discourages telomerase formation and telomerase activity. So through which we can stop the cancer cell growth. So that's why this G quadruplex DNA targeting or G quadruplex DNA stabilizing compounds. If the G quadruplex is stabilized in the genome, then it can destabilize this telomerase enzyme, through which we could stop the cancer cell growing. So far one of the compound is entered into clinical trials. The gorfloxacin is stabilizes the G quadruplex, but due to some side effect is come out of the things. That's why the G quadruplex stabilizing compound is received much attention in this field. So based on this, we develop some compounds like so targeting the G quadruplex. I developed thiazole orange conjugated with the macrocyclic cyclan. So this thiazole orange is can able to bind with or detect or sense the G quadruplex. This center may act as metal ion binding. Okay, so so we interacted with G quadruplex. So the fluorescence intensity increases after binds with G quadruplex. So what the mechanism when this dye is are bound on the this G quadruplex surface, this coplanarity of this ring is maintained, through which the fluorescence intensity is increased or emitted. Okay, and also we can also interacted with the BCL2 I-motive DNA. It also shows increase in emission density. Okay, so what the important thing we found, then we after bound with this G quadruplex and I-motive, we interacted with added with different metal ions. So what the effect of metal ion on this binding efficiency? So when we add different metal ions short from manganese, iron 2, like cobalt, nickel, so all those things. When you add copper, there's a quenching of emission densities happens. It's very selective towards this the copper. So what then we added in order to whether this is strongly bind or weakly bind, we added EDTA. You can see the second level is added EDTA. Even after EDTA, so it's now the copper is not come out from this complex. EDTA is very strong chelating enzyme, right? So the copper is very strongly bound with this here. Maybe the copper may coordinate here and affect this quenching. So like this one, before adding copper is non-selective. After adding copper complex, the selective one. And also we tested with different I-motive and G quadruplex. So compared to all the metal ion, the copper is showing effective quenching in this case. And also we compare with normal thiazole orange, without this macrocyclic, but copper quenches some extent. But compared to macrocyclic, the quenching efficiency is very less. Then we conclude that so for quenching of this the fluorescence intensity, the macrocyclic ring as well as copper is mandatory one. Okay, then we test with in presence of all the metals, the competitive binding studies, even the presence of all the metals, the copper affects more quenching. Okay, so compared to duplex DNA, this shows more selective towards G quadruplex and I-motives. Okay, so then now we are the work is progressing to test cytotoxicity and all those things. We are in the progress. The last part of my talk, so take another like 5 minutes, conclude it. Then now targeting protein and also the enzymes. So as I told you, in the cancer surveillance, the cancer cascade, many proteins are involved. Many proteins are involved in acting as an enhancer protein. Enhancer means help the cancer cell to grow. Those proteins are the cancer enhancer proteins. Some proteins are suppress the cancer. For example, P53 protein is suppress the cancer cell progression. BCL2 family proteins it enhance the kind of cancer cell progression. Okay, so if you target like BCL2 family protein, you target that. If you quench that, if you inhibit that protein, then we can control the cancer cell growth. And also some of the proteins which are help to grow. If you identify, if you selectively target those proteins, you will be able to stop progression. So in the kind we aim to target one of the like aldo keto reductase family protein that's called AKR1C3 proteins. Okay, the protein is kind of hydroxysteroid dehydrogenase type of protein. It's kind of a steroidogenic enzyme that's present in our human to it does some metabolic activity in the case of breast cancer. Okay, the breast cancer is often hormone responsive. Estrogen and progesterone to be main hormones involved in growth of breast cancers. If the prostate cancer is dependent on androgens like testosterone and similar hormones that can help in grow and extract. This the hormones are expressed more or present more that leads to the prostate cancer as well as breast cancer. This AKR1C3 involves or catalyze the formation of production of more of this the hormones in our body. So if you target this AKR1C3, if you inhibit the AKR1C3 through which you would be able to stop cancer cell progression. Okay, so that's our main strategy. So this drug molecule indomethacin is already present in our market. So people are using to control this, but even though it has some kind of disadvantage. Okay, so in order to replace, in order to finding some alternatives. Okay, we are trying to synthesize some of the analog compounds similar to indomethacin. We synthesis. Okay, this carboxylic acid containing, the sulfur containing compounds, because this indomethacin also has the carboxylic groups. So when we aim, maybe the carboxylic group may help this molecule to inhibit this protein. So not to find that, we are going for docking studies using the in silico methods. Okay, here using the Schrödinger software, you can use indomethacin. We find what are the sites involved in inhibition, like enzyme lock and key methods. Okay, and also our compound, the acid compound also we tested. You can see here this nitrogen group, this carboxylate, and aldehyde group and all involved in this case of this the binding sites. Then if you see the score, docking score, the binding score, you can see here acid source -10 kilocalorie per mole, almost equal to indomethacin. It's not over the indomethacin, but almost equal to indomethacin. So it can be a kind of similar analog kind of things, indomethacin compounds. Then we tested this one with the cytotoxicity by using a triple negative cancer cell lines, but this compound is not cytotoxic. This is very interesting one. It's not kill the cancer cell, but it could be able to inhibit or stop the function of AKR1C3. So some of the drug is acting as not killing the cancer cells, but it stop further progression, stop further growing. The same way, so we see here the Western blot unit. If you see, the first one is the control protein AKR1C3. If we add indomethacin, there is some kind of inhibition. But yes, our compound, there is no much inhibition if you take only our second well. If you come second well, is a control. If you add doxorubicin, it's a combination therapy. But normally doxorubicin it's not inhibiting AKR1C3. It's kind of the compound, the doxorubicin has this non-steroidal based thing. Okay, the AKR1C3. So it's not inhibiting that. It's not doxorubicin not inhibiting this AKR1C3. Okay, but when you have kind of a combination therapy, it somehow works and inhibit the formation of this one. And also our compound also in the case of combination therapy. Okay, in the case of combination mode, it inhibits there is no AKR1C3. But when you use alone, aside, there is no inhibition, there is so much inhibition. After combination with doxorubicin, there is a synergistic effect. Okay, due to the synergism. So we could find the mechanism, we have to find actual mechanism what is going on. It's preliminary results we are showing here, the unpublished results. Okay, so we are finding the mechanism how it acts when you have the combination way. Okay, So like this way is we are particularly targeting a K1 So far whatever talk, so I think I given a justification to my topic, like we are like making attempt to target the cancer cell and leaving normal cells healthy. We are trying, but still long way to go. We have to do like in vivo studies. Still we have to find some way in vitro studies. We have to find many ways. Okay, so I think with this I'm concluding my talk. So if biology and chemistry, the handshake. I'm not, that's why not I didn't put the conclusion one. Okay, summary one is still long way to go. This field is continue to do lot of wonders. A chemistry and biology, handshake together will make wonders, lot of wonders in biochemistry. Okay, so like this, I would like to thank my collaborators, the funding agency. So far, CSR for funded my young scientist project. Then some of the fund from CSR received. Then UGC for awarded me a Raman Fellowship. Okay, I visited 1 year USA. There I carried out PDT work on this G quarter plus and I motive binding work. The PDT work mainly I have done in Professor Jonathan Lowell in biomedical engineering department, and most of the work like the I motive water plus binding work I have done in Professor Janet Marrow lab, University of Buffalo. Okay, University of Buffalo, like New York City. Okay, so like this is our research group. This last year research group. Okay, this one is present current year MSc students and PhD scholars and MPhil scholars. Okay, so here, so small research group. This is my lab background. Is there my lab? You can see the master plan of our Central University of Tamil Nadu. So these some of the students are here, and some of the faculty may not aware. Our university is 10 years old university. It was established in 2009. Okay, under the Act of Parliament. So it it has 516 acres. So one of the river like Vettaru is bisecting our campus into two. So one side is a technical like side, official site or the campus. Another one is a residential campus. So in the official campus, all the like activity, teaching, research, like all the labs, everything is located this side. So this side is residential campus. We have KV school too. Okay, Kendra Vidyalaya school. Then assistant professor quarters, associate professor quarters, and professor quarters are there. This is our central library. You can visit our university. You can see this admin block. Then the quarters, professor quarters, kind of a villa type. Then our multi-purpose auditorium. This is our chemistry department. The interior view of our chemistry department. You can see here. This is our like laboratory. Particularly my research lab. You can see here my research lab to design to work 8 to 10 people efficiently. You can see one side instrumentation room. So other side is the fume hoods are there, like 5 fume hoods we have. So we can do effectively all the research and all the duct facility. So all the facilities recently established. Then from 2018 onwards, we are effectively using our laboratory. So like those who are willing to join as a PhD student, as a master student, we are offering chemistry department offering integrated MSc 5-year program after +2. You can join directly. You can do your like an MSc course. Okay, the 5 years course. Then we have 2-year MSc program also. Those who are pursuing BSc chemistry in Vivekananda College or some other college, you can also join as a MSc student here. Okay, through entrance exam, common entrance exam. So it will be conducted through like overall in the across the country. So like national level exams we have to attend, through which you have to come. Then also we are offered for MPhil program. Now we are going to stop that because as per the new education policy, MPhil program will not be valued. Then we have also PG diploma in lab technician 1-year course also there. After BSc you can also join and get some training, lab-based training. So through which many students got no job opportunity in pharma like companies, like chemical companies. Okay, so only 6 students uptake, will be like 6 students. Okay, so you can apply. You can like I think 8 students here now in this seats. They can come. So those who are cleared the entrance exam for PhD, then we have the interview. So if we select the interview, got through the interview, we will be getting 8,000 rupees stipend per month for 4 years to complete your PhD. Okay. So within 4 years, if you are good enough to publish a paper, you can get senior research fellow from CSIR and ICMR, some other funding agency, but university will support, okay, 8,000 per month, okay, like 4 years, we have very good hostel facility, no married research scholar hostel and also married research scholar hostel we have. So like, no, you can come and do your research even with your family too, okay. So these are the opportunities. I think from this year onwards, there's no entrance exam going to be all India level, all central universities, 44 central universities jointly, they're like conducting this entrance exam through National Testing Agency. You are looking for the advertisement. So very frequently, very often, okay, check in our university website www.cutn.ac.in. So maybe the advertisement will come in the month of April. Due to COVID, normally we advertise in the month of March, but due to COVID, this advertisement is takes some time. Okay. So thank you very much for your kind attention, your time. So I took little so a short time, I think so. Thank you very much for your kind attention. I would be very happy if you have a question. Okay, I would be happy to answer that. Okay.
Thank you, sir. May I audible?
Yeah.
Yes, thank you for just bringing the complex world associated with cancer therapy to our listeners possible through a bridge called biochemistry. And it's a time for audience may ask 1 or 2 questions to Professor Rajendran. He's happy to answer. Yes.
Yeah, even if possible that they can turn on mic and then ask. That's not an issue.
Yeah, some of the students also there, you can interact with some basic doubts also.
Yes, that also they can do. So don't feel bad like whether your question is right or wrong. Okay, even a very basic question you can ask me. So like through asking question we can learn.
Sir, any summer fellowship programs are there, sir, in your institution? May be useful for the students.
For summer training fellowships, you mean?
Yes, summer training fellowships may be useful for
Raja.
MSc. Yeah, I'm Raja.
Yeah, we are not right now. We are not offering any fellowships for summer training students, but they can come and work on their own expenditure. But we are providing hostels with some reasonable rate. Per day, I think 100 rupees they would pay for the staying, and like excluding food. Then the food also they would pay separately.
I think the MSc students are struggling for project. Yesterday, Muthu also discussed with me.
But through INSA summer project they can come. Like INSA, they are offering fellowships or some other like funding agency they are giving fellowship through which they can come. But normally if you go some institution, they have to pay money for even doing internship. Okay, but we are not charging that. That is free. We are giving lab, chemicals, everything we are giving free. Okay, but accommodation they have to take care. But due to COVID, we are not encouraging. Last 2 years, we are not encouraging.
Yeah, nowadays that's also a problem.
All the institute they are doing like that. It's a problem. But previously, even in my lab, so far I think 6-7 students they came from different institutes. They completed internship. Okay, but through their own arrangement they came. Okay, but one this way is INSA. INSA they can apply to INSA. Then you can give my name and other faculty members in the department. So through which also you can come over there.
Yes, sir. Thank you for your valuable information, sir. Thank you, sir.
Thank you, Dr. Raja. Sir, myself, I had 2 queries, couple of queries.
Yeah.
So regarding to your copper-2 complex, rhodamine and silver nanoparticles work, I think so.
Yeah.
So you stated that cancer cells are enriched with glutathione, which has a better binding with the silver nanoparticle. But gold nanoparticle have a foremost binding efficiency while comparing with silver nanoparticle. Why didn't try with the gold nanoparticle?
Yeah,
because glutathione itself has sulfur, I think.
Yes. So like due to soft interaction, glutathione has more things, but the only thing is based on the cost effective. Okay. The gold nanoparticle is costlier than silver, so we are trying to work out like a very cheap, some kind of user-friendly way. Even silver is not advisable. We should go like still some more like biocompatible would be nice, but at least silver better than gold like that we thought. So but compared to like silver, gold has more binding affinity.
That's right.
Because of like sulfur and gold has soft interaction. but the main thing is, like the simple thing, the whole silver nitrate, from the silver nitrate we could able to make nanoparticles, and that's only thing. Okay. But gold is a little expensive. That's only, yeah.
And one more query is whether you have add any external dye during the fluorescent imaging of the same work. Because the rhodamine color itself has some pink, but I could visualize some red color, I think so, in your imaging studies.
Yeah, yes. The thing is, we didn't use no, anything, but this kind of fluorescent imaging thing, the fluorescent image, even sometimes, you could be able to change the color of the image also, not to distinguish, people are not to distinguish, they change the color there itself. Okay. Sometimes, the original, thing, the fluorescent means it gives like kind of a bright light. Okay. And now, based on the software, they know in order to distinguish, sometimes you can see the contrasting color they know. They are making.
Yeah.
That is there. But we are not adding other than rhodamine in this. Okay, rhodamine, as I mentioned, is kind of a tracking dye. Whether it will get into the cell or not. Okay, because copper is it's not a non-emissive compound, complex. We cannot know whether it is get into the cell or not. Only we can know after testing the cytotoxicity. Only we could be able to say, okay, copper is get into that. Even then, some of the people are saying whether the cytotoxicity due to the copper or some other thing, may not know. Okay, so that's why we are co-loaded with rhodamine. Okay, we make sure that this nanocarriers enter into the cancer cell like that. We conforming through this rhodamine.
Okay, sir. Anyway, thank you so much. Just like your abnormal cell division, your abnormal growth in this particular field definitely inspire not only the researcher and also the students. It's really a proud moment and a proud day to our department as well as the management of Vivekananda College having you. So thank you so much, sir.
Thank you very much for your nice words. But it's really challenging one. Easy to talk on the slides, but working is not that much easy. Like purification of compounds, dealing with the biomolecules. Another thing is really expensive. All the biomolecules are really expensive. If you're not carefully handle it, you may lose 10,000, 20,000 rupees per day. Many things are there. It's very challenging. Cost effective. One is the main thing is that cost effective. One can want to do research, first looking for a fund in this field. Otherwise, it's very tough.
Exactly. Okay, sir. Best wishes. Now I hand over the session to convener of this FEP7, Raghu sir. Sir, please.
Okay, sir. Okay, sir. Thank you, sir. Now I call upon Mr. A. Dharmanandam to propose vote of thanks.
So good afternoon to one and all those who are present for the meet. Initially, the total number of participants were 96, but since at the end of this session, due to other commitments students had as internal examination, the number has dropped to 23. So first and foremost, it's an honor for me to propose vote of thanks. I thank God Almighty, Bhagwan Sri Ramakrishna, Mother Sharda Devi, and Swami Vivekananda for all their blessings from the beginning till the end of this moment, for a proper connectivity and a proper approach and a proper delivery that happened all through this faculty enrichment program number 7. Then I thank the management, secretary, principals for offering us the financial assistance of a college with potential for excellence UGC grant to host this faculty enrichment program. I thank our HOD sir for calling upon all the 3 resource persons from 3 big institutes and arranging all necessary requirements to host this FEP program. Then my sincere thanks to the 3 great scientists who delivered the lectures today, Dr. Devraj sir, Dr. Nehru sir, and Dr. Rajendran sir in particular, who is present now, for a wonderful lecture which they have delivered today. So we are feeling extremely blissful to hear all your lectures, sir. Since due to time constraint, we could not progress beyond the time limit. So thank you so much for all the 3 resource persons.